Hey everybody. Okay, now we are live. Hello and welcome. I am Jacqueline and this is...
I'm Tim and we're here building. Do we have the right view up?
This is not the right view.
There we go. Okay. Hey everyone. Thanks for joining and we hope you enjoy us today. We're going to be building a Powerfully MOAI 3D printer behind us. If you have any questions, anything you want to know about 3D printing, feel free to leave a comment in the sidebar or wherever it is on your screen, and we'll hopefully see it and get to talk about it.
Yeah, and let us know in the chat if you can hear us. We've never used OBS before, so this is a new adventure. And I've never built a printer before. Tim's built one, but not a printer that has a laser in it.
No, definitely not a laser. This one's the first. We're really excited for this one because it brings a whole new level of opportunity for what we can build. And I think we'll see a lot of cool things coming on the channel in the future.
There's only one pair of safety glasses in there, aren't there? For the laser.
I don't need eyes.
So we have the chat up on the side right now, but when we go to open the box, we're probably going to have an overhead view of what we're doing and then us on the side, but we will have a pop out of the chat so we can see what you guys are doing. And if you want a closer up view, we have this over here. And we can zoom in on whatever we're working on so you can see it.
Cool.
So David says it sounds fine. So
awesome.
We're good. So we can crack open the box and start to unwrap the printer. Also, Tim has not read the instructions for this. Only I have, so good luck to us all.
Yeah, it's kind of bad, isn't it? So I'm going to get this set up and we will...
And I'll do the 2-camera overhead view. This iPad has the slides with the instructions on it.
So we get to a live unboxing too. I actually don't really care for unboxing, but it's probably good to keep everything in place. While we start this.
I'm sorry that the table is a little bit wobbly.
Yeah, we gotta weld one up in the future. There we go. Okay.
This printer box comes in like 4 different layers of all the materials that we're gonna do. Do you want to put it on the bench and we'll just pull stuff out?
Yeah. Oh, I like it already. There's a sticker.
Tim does like stickers.
All right.
So this is layer 1.
We can't. Which the first thing we do, we have, I believe this is some calibration paperwork and stickers and stuff. We don't need these right away.
Laser warning. You can just pick it all up together if you want, or if you want to do one layer.
Pick it up.
Maybe one layer.
One layer at a time?
Yeah. It's heavy.
It is a very heavy box, so I was actually kind of scared at first.
Ooh.
With the galvanometer.
So this is the lasery bit over here. And this is my favorite part. This is all the electronics.
Some acrylic. I don't know if we'll get to put all the acrylic panels on today.
Tim's gonna drive this back home and he's gonna calibrate it there. I can unwrap this all right.
Yeah. So we do need to inventory everything with to do.
I might change it back to the...
This is the build surface, build plate. This comes in the vat.
There.
And it goes up like this and your parts built underneath it.
Yeah, so instead of the regular 3D printer that, you build upwards, it's the opposite. It's actually pulling the print out of a bed of resin, which is pretty interesting.
Yeah, and there's a bunch of different resins you can use. There's
safety glasses.
Yeah, the resin is really the cool part about this printer. It allows, with the laser, detail on the order of about 70 microns. So you can make exceptionally detailed parts, and they can have exceptionally detailed parts. There we go. Really gonna say. All right. There's a very unassuming box, so if you do order it, it's kind of cool. You can leave this on your porch, and no one would know it was a 3D printer, which is nice. Everything's in like a cutout box here, a cutout foam, plastic.
The design allows for more interesting overhangs too.
Yeah, you can do a lot of. Let's be careful there. So you can have overhangs, but you have to have a good support to build off of. So, in theory,
they can't see you.
In theory, the post you could make, like if you want to just make a vertical post, it could be the size of that laser spot. But in reality, it's going to be a variation around that size.
So what I found most interesting about the overhangs for the 3D printer that we have that just is the regular one that prints PLA. The overhangs are just the same kind of material, and then it's just a matrix that has less infill, right? And you just like snap it off, but it doesn't look as interesting to me as the ones I've seen for this SLA. The SLA looks like if an alien was to take over a spaceship, like how their tentacles go. Personally, that's what I think about, because it like starts kind of thin at the base and thin at the top too, because it's a different, like it's harder to break these off, right, than it is for.
You have to build a lot more support. So typically, let's say this was
so
our
like
part.
Snap it off though.
You would build it like on your FDM printer. You'd build it like this, but in an SLA printer, you might print it something like this and have a lot of supports building off that platform, just to help get it off the platform, but also to not have as much of a support requirement.
So to tell you more things that we're pulling out, these are the circuit boards, and these blue things I believe are the potentiometers, right? For these ones.
Yeah, they're the trim potentiometers.
And they've been calibrated for this printer, and that's why
they glued in place.
Yeah, so we don't want to mess with those. We don't want to touch those because they're pre-calibrated for this exact printer. And what Tim's getting out right now, this is the Z-axis. So this is what
I'm getting it out.
This is what the build plate attaches to, right?
Yeah.
And then the Z-axis is just going to pull this up slowly. It's not like with our regular printers that we have, where the Z-axis is actually moving the print head back and forth. So that's layer 1.
That was only the first layer.
Of 4.
Oh wow.
It comes with some tools. This nice scraper right here. I'm guessing this is for your actual prints to get them off of the bed. Socket head. And then
nice powder coated steel. It feels like it. Maybe it isn't.
This is where the riser motor attaches for the
oh, this thingy.
Yeah.
So this is the vat goes on this.
And the vat is full of resin. So what happens is a laser shoots into some mirrors. The mirrors move the laser in the X and Y direction, and that hits the vat of resin that's over there and creates the shape that you want for a layer. And then the build plate lifts up the Z-axis just a little bit for a layer, and then that has a vat of resin that tilts, right, to re-level it, and then we do the next layer.
This is cool, this piece here, just because I do a lot of design with some of these type of fasteners. This has clinch fasteners inside. They're actually, these are press fit. You'll be able to see them if you're up close, maybe with that other camera. Maybe we'll show it in a bit. But these are all these little threaded pieces here. They drill a hole and then they insert the threaded piece. And so where it inserts there, it's press fit, and it's just, you can vaguely see a hexagon on this side where each of those were pressed in.
So this is the front plate of the whole printer, and this is your little control window. This is where the screen will go, and I believe this is where the lock goes, because you don't want people looking at the one, you don't want people looking at the laser, and 2, this is UV cured. This is power.
Yeah.
There's another one
Well,
somewhere.
there's a door up here that opens. That's where the lock is. Yeah.
So this is the power button. This is the window. But there is a lock on it so that people don't hurt themselves with lasers. And there's all this black acrylic that goes around it. Did we already say why?
No.
It's because it's UV cured. So you don't want any UV light getting to it. So they have the black acrylic. Can you take...
And you can...
You probably need to take
smell
this
stuff.
and put it farther away so we have more surface. I think these are all just the side panels, right?
Acrylic panels? Yeah.
So these are the acrylic panels we were talking about. They have tape on them right now. When we take the tape off, we'll wear gloves so it doesn't get all smudged up. This is the actual frame of the printer. So this is the front side, and then the back side's over there, and then left and right are these. This is the first part that we're going to build.
The frame.
Here. There's a PowerPoint of instructions that we're going to be following. I think it's like 71 slides.
More of the acrylic.
There's a bottom layer. I'm just going to take this. You just want to take this part away? Yep.
Yeah, I'm going to put the acrylic back. All the acrylic pieces are going to go back into there. And this is the door. There's the door.
Where are all my cable harnesses?
Probably in one of these boxes. That's where the wire harnesses reside.
I'm just going to take the box.
Yeah. Even this is really heavy. There's like a little weight in the bottom. Maybe this box is just like there's wood in it. I don't know. Acrylic is heavy. I think most of the weight might be the acrylic for this printer. I was terrified. This box is like unwieldy. Even right now, it's heavy.
So the first thing we'll do is to build the frame. I'll change the view for you guys. You're going to need to get hex. I thought it came with hex. It doesn't. So they're the top. Yeah, I know. So I have this really nice set of like ESD tools, and it's got like a wire stripper and needle nose, and it also had this really nice hex set with it. And we use it for so many projects that we have, and we haven't been able to find it for like a month. And that's our best set of hex tools. Should be in the very top. I'll come. You come back over here and talk to them, and I'll come look.
It's a set, right?
It's in just a Ziploc bag. You can come back, Tim.
Yeah, a Ziploc bag. I will look. Give me one more minute.
So I'm going to change you to the messy overhead view. And these are our slides for our instruction, and I'll move some of this out of the way. Oh, I don't know if you guys saw this with a Z-axis. This is our little stepper motor, and it's already pre-wired. I think most of this stuff is pre-wired, no soldering needed. So I'm going to put all the control boards back. So the first thing we'll do is set up the frame of the printer, and then we're going to install the Z-axis, and then we install the tub.
For sure there's no... I think this is the Galvo.
Put this all behind.
Got the laser bit. I did not get tools. We're going to use fingers, and I'm going to file it down to the shape of these. I wanted to see if there's your cables, your wires.
And there should be like a ton of bags of screws of various kinds.
That's the back.
That's where the resin goes. And there's different color resins, right? Like there's different color PLA filament. You gotta keep talking, Tim.
Yeah, it's different color resins. There's different materials too. So I started off with just a couple basics. I got a neon green, a gray, and a clear. We've been talking about doing some castings. You can actually get a wax type that will allow you to make a model, and then you could put that in an investment casting, basically plaster, and then you heat it up after the plaster is dried, and you heat that up, let the wax melt out, so you have some sort of pathway where you get your metal to flow in, and you let the print melt out, and then you melt the metal, and then you pour it into the mold, and when it hardens, it's the shape of that piece that you cast. Sure. It is a casting of your 3D part. So if you wanted to make some little figurines or something, maybe Dungeons and Dragons or some other board games, and you found some designs online that you really liked, it'd be a good way to make some really durable parts.
Are there hex wrenches in there?
I found a tool. We got snips.
I hope there's hex wrenches.
Hey, there it is. Probably have a counterfeit Kingston SD card. Who knows? It might be real. There's some tools here. There we go. There are tools. Thank goodness. And tweezers. Did you find your tools? Oh, this was the bag? Okay.
Yeah, it's not good though. We'll just get rid of it.
Yeah, so there's screws and things in here.
So we will need to get out the BH M612s.
M6 12mm links?
Yeah, and I think there's another one we need. No, just that bag.
Okay.
Oh, and 20s. I thought there was 2 different sizes.
The 20 link?
So, we're going to put ones in the left and right bars first. We're going to put some
These aren't labeled, but I think those are
We'll find out.
longer.
Rarely just have a box of them.
What I'm going to do is actually spread these out.
Ooh. And it comes with this SD card because this is for, I think, your calibration.
Oh, that's what's on it. Okay.
Yeah, and you have to
Hefty hinges.
put the G code on here. And what about the slicing is different, a little bit different too, right? Because with regular printers, I'm going to call them regular printers because I think
FDM, so like the little
FDM.
spot over there.
Yeah.
It has.
They, like you were saying, they have support structures on them. And they kind of build up this way. But with the resin ones, you need to have drain holes in it because it's a liquid. So there's actually stuff contained inside of it. So you have to make sure that you build in some drain holes when you're doing it. And there's, like, for the little spot we use Cura, and that slices. All I have to do is Tim makes something in CAD, or I download it from Thingiverse because I don't CAD yet. So after that, I put it into Cura, and that goes through and slices every layer and tells the print head where it's going to go in the X, Y, and Z direction. But it's a little bit different for this printer, right?
It's only different in the start. So with this one, we take the first model that we get, and then we have to put it into a software, like one is Autodesk Mesh Mixer, and then we generate the support structure. So remember how we were talking about, we should have a 3D model to show, but
The alien arms.
yeah, so you have to support the SLA part a little bit more than you would some of the a little differently than you would some of the FDM parts, or the FFF. The fused filament fabrication is what we call the open source printers. The model then generates a new file, and that file goes into Cura, and then you use Cura to do your slicing, and your G code is the same. It's the same G code type, line by line code that you would have for your FFF printer. So it has all the other filament printers.
Tom says, "Happy Saturday."
Hey Tom, how are you?
I wonder if Tom and his daughter are going to build this as one of these printers as their next printer. Are you guys going to build an SLA? Yeah, you got everything out of that box.
Yeah, I did. So There's an assortment of screws, some tools that are probably going to last us this build. This is a screwdriver. I don't know which camera you can see it on. But
Can I have the left and right thing so I can start building?
left and right.
Tim just wants to organize. I'm going to start building.
All right, left, left. 1, 2, and 3.
Yeah, we'll start with lefts.
Okay. I'm going to move some of this stuff out of the way. Do we need any of these next ones soon?
These are the only ones we're going to work with for a little
All right.
bit as we build out our frame. So, like I said, first we're going to build the frame structure itself, and then we're going to add the Z-axis part, and then we're going to add the bed for the vat that's going to tilt, and then the motor for it, and then we'll do the structural components, and then we're going to add the electronics. And we're not going to add all the acrylic side panels because Tim has to take this back and calibrate it, and you need the side panels off to be able to calibrate. And there's a couple different things you have to do for it. That's printed out circle paper as part of the calibration where the laser, you see if the laser actually traces pretty close to the circle for the X and Y, and then there's a bed level calibration for the Z. And apparently, I think it's really important that the first layer is definitely flat, right? Because it's adhering to it and pulling it up against gravity. So it's pretty important.
Right. That's true.
I learned some things.
Yeah. And Tom, you're just catching on. You're just catching up now. Jacqueline actually read all the instructions. I haven't had a chance. Oh, yeah, the Prusa is a good printer. Yeah. Yeah, I haven't had a chance to actually look at these instructions yet, so we're going to do this live for me.
Yeah. It's going to be interesting. Oh, there's an echo? Hopefully it got better. We can turn if we need to, we can turn down the gain.
Oh, he said never mind. Well, I turned it on mute. Did it go away?
If it comes back, let us know.
Yeah, we aren't sure if it's picking up like just the one mic or if it's deciding to go to all the other mics. And
hopefully that worked. I just turned off one of the mics. If you can't hear us anymore, let us know. So the Yeti should be picking it up. All right, Tim, you need to, for the left 1 and 3, you're going to install these. And you want to screw them all the way in and make sure there's no burrs or anything, and then back them out just a little bit. So we use OpenBeam for a lot of our projects. It's what we actually build our teleprompter out of. It's what we did some of our physics videos with, and what else have we built? Oh, Sophia, the Sophia box.
Where is it? I just saw it.
I'll look for it. You keep doing that. We sent an experiment up in a NASA plane, which I'll get that video out someday. Keep talking.
Yeah, so that one we put on a NASA plane. It was the Sophia, SOFIA, and Stratospheric Observatory for Infrared Astronomy. I think that was, but it's basically a 747, and they modified it with a huge cryogenically cooled infrared telescope that sticks out of the back of it. And we knew somebody who went on a flight on that, and they took our little payload that we made here with them. And what we have on this is a Geiger counter, and we had an Adafruit proto board on the other side, and we had a Feather M0 Ada logger, so that one had a SD card, and there was also a GPS. So what we did was measure the altitude, and I think we took the speed as well from the GPS, and we had put that on a plot with the radiation that we picked up.
So we were trying to see if, with a Geiger counter, the higher up in the atmosphere you went, the more radiation you would see. And that's what this was all about. So we built this Geiger counter from a kit, like we're building this printer from a kit, and we did this board for the GPS. and for the feather on our own. And we put it inside of this little open beam box. It was pretty hard to cut acrylic.
That's one thing I learned how to do acrylic cutting with the tools that we had.
We shattered some things first, but my point was, with this is made of open beam, so you just slide the screws down the extrusion, and that's pretty much what we're doing with this printer right here.
Yeah.
Is making kind of a box like this one with black acrylic on the outside instead of this clear. And did you tell them why it flies above the clouds?
So it's an infrared telescope, and it needs to fly above the clouds because the atmosphere, all that moisture, it interacts with the the wavelength of the light. So it will, instead of the light rays coming straight in, they'll distort and diffract. What's the word I'm looking for? One of those words.
They're going to bounce off and go back into space. They don't come through the clouds. And you can test this out on your own, too, if you have, like, an IR sensor. I did it with our Lego robot. I actually just, I used a vegetable steamer and made some steam and put the robot in front of it, and you could see that the IR sensor didn't work anymore just because of some steam. So the IR doesn't come through the clouds, so they have to fly above it. But it's really cool to have a telescope on a plane because when something interesting happens, you're just like, go fly over there. So for the New Horizons that went out to Pluto, they wanted to take some measurements of Pluto's atmosphere. There was an object that was going in front of it, which is called, occultation? It's something went in front of Pluto, and so they could see the outer atmosphere of it. And they had New Horizons that was trekking out there as a satellite, do some observations, but they also flew Sophia directly where they could make some observations. So not only can you, literally on the fly, go and find the thing that you want to observe, they can also upgrade the telescope, which is really cool. So as technology advances, they make new instruments and put it on the plane. And did you tell them they cut out a giant hole in the side? Obviously, you have to open it up to be able to use the telescope itself. So that was pretty cool. Here, I'm gonna let you see this. And they had to do all kinds of testing, aerodynamic testing, because you have a giant hole in the side of your plane, which isn't what you usually want in a plane when you're flying around. And they had to have a lot of stability because you need very accurate measurements. So they have to make sure that it doesn't move at all when they're flying around. So did you have the left and right done? What did you do? Why isn't anything in there?
I thought we were just deburring. Now I see we're supposed to put screws in.
I said put them all the way in and then back them a little bit out. I think it's only for the odd ones.
And this is so we're going to slide them in?
Yep.
Okay. So in that case, I know exactly how to do this.
Okay. So we're going to, the key is the labels are always on the outside. So this is, I think the back side goes this way and the front side goes this way.
I think I should have brought the granite surface plate, but we'll see. We'll see if we can make this super square without.
It'll be fine.
We have a metrology session.
Tim is very meticulous.
Yeah. Maybe I'll disassemble it and make sure it's absolutely perfect when it goes back together, and then I'll calibrate it.
Did you read the instructions?
No, I didn't.
I just sent you. I'm going to take the PowerPoint back. Because I don't think...
Yeah, I did. This is the left.
Yes.
Was the left supposed to go in? It says...
Go to slide 4. Left 1 and 3, not 2. So these are all labeled. Maybe it's better to do this one. I don't know if you guys can see. So while you figure that out, I'm going to tell them more stories. Here's the other bag.
I've been on this no coffee kick. It takes a while to get used to not having coffee.
So what's going to happen is we're going to slide it. I think 3 is at the bottom, and then 2 is here, and then 1 is at the top. And 3 is going to have hold in the base plate for us, and on the base plate is where all the electronics are going to be screwed into. And then they're already connectorized, so we attach them all together and route them, and then I think we just use zip ties to put them together, which is very foreign to me because I came from a world of wiring where zip ties are forbidden. We use string to tie everything up because zip ties can sometimes crunch the outside. So aerospace world. I think they use zip ties in the military, but not so much in space applications. You also have to worry about off-gassing. So when you go up into space, things releasing gas. A lot of things, I think all the string that we used, can't remember what the name of it was.
M43422 or something like that?
It was
string?
It was all baked. So there wasn't any outgassing once we went to space.
Is it wax-coated? The wax string?
Kind of felt waxy. So there's special, we would have to take a class on how to tie the knots around the different wires. And then you also put it inside of convoluted tubing to when you need to route it more protected. And there's different strings, I think, that we used at different parts. And we also had special tape. It was called Mystic tape that we would use to do repairs. If there's cracks on the outside of the protective covering, that was Kapton wire. And if you had any cracks in those, you definitely wanted to cover them up because you don't want sparks between two parts of the wire to happen. So we'd use Mystic tape to repair them. This is going to take 3 hours.
Oh no, these are good.
Okay.
I'm on the third set of instructions for the bars.
Oh, for the left 2 and 3?
Yeah.
So I'm gonna slide. No, I don't know which side it is. Oh, wait a second.
You need instructions?
Yeah.
We find the assembled front and back frame labeled. Did you guys want to see the instructions?
It's okay.
Okay.
Put the front to the left.
So you're looking at the front.
Yep. The front is on the left and the back is on the right side. And then I think I take the right one and pull it down. Can you go to the next one, please?
Can I just go to slideshow? Or no?
You can. It's the play button.
No, never mind.
Okay, so I'm going to put the right.
You need the right one, right 2, right 3.
So I'm trying to see if they can. You put the screws kind of in, and then we just slide it down to the bottom. Makes a lovely noise.
There's caps on the feet here. Maybe it might make it easier to take that off.
I was going to pull apart your printer. So we got right 3 in. Do you want me to put right 2 in?
So right 1, right 2, and right 3. Now we might need to go in a little bit more. But right 3 is over there. And what I'm going to do is actually just kind of come in here and I'm just going to lightly screw down some of these. We're supposed to do. I'm going to double check this.
So there's, yeah, that's okay.
No. Right 2 is not going in.
And there's holes in the sides over here for us to screw them in.
This,
Did you use the different screws?
I did something wrong.
There's 2 packs.
I did it wrong. So
okay. The evens got a different number than the odds.
I know that.
Did you do it reverse?
It says these are for the screws are for the left 2 and left right, but it's supposed to actually come from the the instructions don't tell you that it has to go like this. The picture does, but the instructions are copied from the others. So the instructions misguided us here. There should be like a cutout on that side for where the screw head goes through, if I'm not mistaken. Right here.
Oh yeah, I have to actually. Do you want to? It's not showing it to them yet.
Okay.
So you hold it, and I'll transition it. When you're done moving.
So the screw head.
There we go.
Here.
You have to go back a little bit.
Fits in this hole like that, and then it goes into the piece.
The other ones just slide.
Yeah. The instructions clearly say screw them in until there is 3 to 5 millimeters remaining out. So let's go ahead and switch back the other view there.
Here we go.
So
I mean, I can talk about space wiring all day. If you have space wiring questions, I'm much more qualified to answer that than 3D printer laser questions. Tim can answer all your 3D printer laser questions.
Okay, so now this should face up like this, right? This is the right side?
Yep.
And does it matter where this goes?
I'll hold it. It says always put the text to the outside because see there's holes.
Mm-hmm.
So I'm guessing you have 3 different plates, and I think all the plates screw into each of these.
Once we get this into here, it's gonna be a little.
I thought about having sound effects because I knew we were gonna have to screw things in. You need like a little sound effect button.
That went together much better than I previously had. Right 3.
It's down here.
That's 1.
This is 3.
That's 3.
3's at the bottom. I think they're the same, but 3's at the bottom.
Okay, we're just gonna we're gonna snug them, but not too tight. If you want to grab 3, we can install 1. Sorry.
Do you want to put the left one in?
Yeah, I can do left. I'll do left 2.
There we go. I can give you more space shuttle facts.
It says to do right 1 before.
It does say
we
to
do
do
the
it.
left side.
It does say to do that.
But you know,
I was trying to speed this up.
Who's checking the rules here?
So the payload bay section in the orbiter, the part of the space shuttle with the wings, that white stuff is not structure. All of it is blankets, and we remove all of it. Hello, Chase. I gotta see what Chase said. Can you see? I have a tripod in my face.
Hey.
Yes, it is brave of us to assemble live. Especially brave of Tim, because he hasn't read the instructions yet.
Yeah.
And he's the one that usually builds the printers.
I usually read instructions, but I have not been...
Chase, have you built any printers or any kits?
I think we're doing well. We got 4 pieces in so far in the first hour.
Gotta remember to keep the labels to the outside. So what's the first thing you're gonna print, Tim?
The first thing I'm going to print is the calibration object.
Boring.
After that, I think I'm going to print some fun bits.
can I tell them one of our ideas that's associated with another one of our projects?
Yes, we can always talk about ideas.
So we said we were going to do that burp test, like do astronauts burp in space. That was one of the things that we were trying to work on. And some of the issues we've run into is, one, the accelerometer that we want to use, we have to write like the library for it. Can I move this a little bit?
Analog digital converter.
Yeah. So we have to, usually when we do electronics, we find libraries that are pre-written and we write some of our own code, but we use those libraries. This time we have to write our own, and we've never done that before. So that's one of the things we're trying to conquer. And the other one is we don't want everything, all the electronics, to just completely be destroyed after one drop. Because, I probably should explain what the test is. So we're trying to figure out if astronauts can burp in space, which we kind of know the answer to. So in free fall, we want to see if we create a burp in some liquid. Do you need a flashlight?
I've lost the part, but I'll find it.
If we release a pocket of air into liquid, like a burp, will it rise? Will it fall? Will it stay the same? What will it do? And so we need to create the electronics package that's going to record what's happening and also trigger the burp itself. And we'll have a bunch of cameras on board. And we're going to try to drop it from as high as possible. So one of the things we would like to print is a lattice structure that will kind of break upon impact and take most of the load for us, instead of just us breaking all of our electronics in the camera. No. Oh, did you drop the foot?
The foot didn't stay in.
It's okay. I'll click it in.
No, this one over here doesn't stay.
Do you want to tighten up your side?
So might have to glue it or something. Yeah, I'll go ahead and tighten these up. Right, so we looked at we may not do the lattice structure for the impact, but that's something we might put in it for sure. I think we have to do some experiments.
And math.
We could also just drop everything and hope for the best. The problem is that we need height. We need height to get some duration for the footage.
For the free fall that actually for you to be able to see something, even if we do it in slow motion, you need a good bit of time.
Yeah, we did drop something from about 30 feet, 35 feet in the air.
Pumpkin or the?
We dropped the pumpkin, but we also dropped.
Did you? Oh, you did tighten that one. Good.
This one up here.
Okay.
We also dropped.
We tried to test out this bungee cord over there.
It didn't work.
It didn't work. The pumpkin did not survive. But we.
Are you sure we did that? I thought we just decided to just drop the pumpkin. And then film it. That's what we did.
Sorry, you were saying in the container?
But the container for the
when we attempted with the container, the testing.
Yeah, we put a camera, and I think we used a little shaker bottle, and we put a GoPro in the bottom of it. We fill it with water, and then we put what did we put in Alka-Seltzer?
We put molasses.
Molasses, okay. And we wanted to show when we dropped it.
It needed to be different densities.
Yeah, the buoyancy force is what causes the burp in humans to occur under gravity.
Right. So buoyancy is why you burp, because the air is less dense and it rises and it comes out. So molasses is heavier, so we wanted to see if it would drop, and it didn't. It just floated.
Denser.
Yeah.
Yeah. All right. Let's see if the foot fell off and it won't go back in.
Didn't fall off.
And that one doesn't quite. We didn't pull it out, did we?
Yeah. Like this one.
I don't have my hot glue gun, so we're not gonna be able to fix these. Maybe we should just flip these around, but I'll see if we can figure out a way to get them in. They're not going in. These we could print.
While you do that, you want to hand me the slideshow, and I'll know what we'll do next. I'm pretty sure it's the Z-axis.
I feel like maybe they deformed when I took them out.
Because we weren't supposed to take them out.
There we go. All right, can I stand this up now?
Yeah.
All right. Our tower is somewhat constructed.
All right, it is the Z-axis next. We're in slide 14.
Are we still keeping this loose?
Yes.
Because we want to add the other pieces before we finish up. Oh, this one could be a little tighter. Do you have the screw, the hex?
Do I? So the Z-axis goes on the back side, and that's going to be what lowers and lifts the build plate.
Left, right, back
Back,
and front.
Front towards you guys. So this is the Z-axis, and we're going to need M320s. This is your box of hardware.
You know, let's see if we can squeeze these under. Just these two.
So if you're building your own, don't take the bottom things off because you think it's going to be easier to slide left and right 3 on. That's a bad idea. That's not the hardware. And after we build the or put the Z-axis on, we're going to put the riser on, where the vat goes and the riser motor.
Yeah, this is the riser bit. So there's a motor, and then basically it drives this.
Would you like to get the
piece there,
Z?
And then this top part tilts.
And 320s.
That allows at every layer, it's going to tilt it to basically refresh the resin on the print, and then it's going to come back down, and then it's going to hit the laser on the part where you make it. So there's a lot of the dust. Oh, Jacqueline, look! What kind of sensor is this?
That's what I was asking before. Oh, it is. It is an IR.
Just a IR sensor there, held in by one screw, and it looks like it kind of fits.
So it looks like it has an IR transmitter and receiver, and it looks just like the one we're using for our robot that we're building, the encoders. And we're building a robot that is controlled by Twitter. So you guys are going to send tweets like left, right, forward, backwards, and control this robot that we're building. And it's got the little IR sensor, so there's a transmitter and receiver, and then there's a little wheel, a little encoder wheel that's called an incremental encoder, so it has slots in it, and it can count how many times that the sensor has a broken and an unbroken. So any of the slots are unbroken because the IR can go through. And I think this was the one that they said to make sure everything's tight on it.
This sensor right here?
These ones. No, not the sensor. No one ever says to touch a sensor. It should be okay.
No, this one's okay. But they don't touch the laser bit. Yeah. So we got lead screw.
Make sure those are tight.
So anything loosened up.
Yeah, so there's a stepper motor at the bottom that drives the lead screw up and down. A lot like your CNC mill.
Yep. Yeah, it's very similar. This actually looks like, so Tom might find this interesting.
Do you want to show them what you're doing?
Oh, yeah. So it looks like we have anti-backlash knot on here, too. There's a spring. And what that does is, backlash is basically if this thing changes direction, this part here may not move. And so what we want to do is keep constant pressure on the nut that goes on the screw that moves the piece. And so when this rotates, it actually continues. It does move with it. It doesn't stay there.
Because, like, if you have 2 gears, right, the teeth are kind of in the middle. You don't ever want them always touching because then it's just locked up and nothing can
on both
move.
sides. Yeah. Well, you're gonna have contact on one side.
Right. But I'm saying that's what you're talking about with backlash. So it takes time for like this gear to touch this one, and that amount of movement is your backlash.
Right.
I learned that with the lathe.
Mine has a lot because it's old and worn out. Okay, so now we have tested and checked our tension I should have brought like a feather duster. It's so full. It's so full of that packaging plastic. The foam is everywhere. Okay, so this now we need screws, I guess.
Yeah, I got your M20s.
Okay.
Do you think we should change the view at all?
Yeah, we could do. We could even put this guy up here and have an enclosed view. Oh my.
I'm gonna wait till you stop tilting it.
How about I do one thing at a time here.
That's a good idea.
And get the screws first.
They're right there. I got them out for you.
I see. And them out of the bin. Oh, so these go in the extrusion on the outside.
It's a good idea to use the Joby. It's very close. So we'll move to this. So now you guys can see it a little bit better, I hope. So there are 4 holes, 2 up top and 2 right here, and we can easily just add the Z-axis to it.
Oh my! Almost didn't grab it.
And I can hold it for you.
Let's go just a little bit through.
So this metal part that's sticking out that you guys see, that is where we're going to attach the print bed. And it's made of aluminum, right?
Yes, the silvery color is the aluminum part, and it's like a matte finish to it, like it's been maybe bead blasted. All of the extrusion is anodized black with the chemical process, and then the sheet metal parts, are the black pieces here, have been powder coated. They appear to be steel parts.
And then down here is where our stepper motor is. So what's the build volume of this? Like how high?
So the build volume of this printer is 120 or 130 millimeter in X and Y, and I think 180 in Z. Don't quote me on that.
It's okay.
It's something around that. It ends up being about 5 inches by 5 inches by 7, if I remember right. Which is pretty good size, and I think I need to feel like I'm cross-threading. So let me check this one out. I might need to just come around here.
I can move if you need me to.
I just need to find the hole here.
It's a tight space. The next thing we're going to do is install the riser bed. Sorry, I'm shaking.
I'm going to take this out. I'm going to look at this real quick. It feels like it's cross-threading a little bit, and I just want to make sure that
you're going to take the whole thing out?
That's not. We'll leave one screw.
Okay.
At the top, just so we can rotate it. That's going to tilt.
So like I said, this is where the build plate's going to go.
It is going to rotate if you can grab the bottom.
The rail that it's going up and down, that looks
that
like,
linear guide?
Yeah.
Linear profile rail?
That linear rail looks like what you have for a lot of your stuff. Tim built a solder fume extractor that goes across his workbench on a linear rail.
I did. It's very similar to this, and we 3D printed a part that holds the whole assembly, and then I used a microphone stand. Yeah, so this holds a little. It probably got some powder coating on it. Just
I
a
have
little
a deeper
tough.
tool.
No, we would need a tap, but I got it. It's okay now.
We're not at your shop. I don't have.
I forgot my bin.
Bins and bins of taps.
Yeah.
Okay. We went to ThinkerCon recently, and we did a collab with Jabril, and it's going to come out on his channel. Sorry that it's so white right there, very off white balance. But yeah, sorry. We did a collab with Jabril, and I wasn't sure what he wanted to do, so we just brought pretty much an entire maker space down with us. Bins and bins of stuff. Tim brought a whole bin of fasteners. We thought we might build like a mini robot or something with him. He's very, very good at machine learning and coding, but he's brand new to hardware. So in the end, we pretty much taught him how servo motors work and made some stuff with him, the servo motor.
With the Adafruit Circuit Playground Express.
Yeah, which
and
is a great starter board. So he'll release that video on his channel. We'll let you know when that comes out. But we definitely brought a miniature maker space with us. And the people he was with, they were really impressed. And I said, we pretty much have a lot of experience doing this because we were on a FIRST robotics team, and Tim and I used to drive the pit. Like, we drove 22 hours in a truck and a U-Haul bringing the pit around, and we would help pack it up. For anyone that doesn't know what FRC is, it's high school students. We were mentoring high school students. They have 6 weeks to build a robot that does something like climb a tower and shoot frisbees, or throw giant beach balls, or knock down castle guard things, like going over moats. And so they have 6 weeks to build a robot that does all this stuff. And after that 6 weeks, they have something called bag and tag. So they have to put their robot inside this giant plastic bag and tag it and then not touch it again. And the only time they have to fix it after that is in the pits, like a NASCAR kind of pit at the events. So you need to bring as much tooling as possible with you. And there was one time when we had a robot that shot frisbees and it wasn't doing it well. And they built a connectorized version of a whole new shooter and had to swap it out in one of the pits. So we have some experience with bringing tons of tooling around with us. Oh, you're on to the next part?
Yes.
So, Tim down here, do you want to show them what you have? It's not that one. Sorry. I looked ahead. You're at this one.
Oh.
You're securing that platform over there. I might...
Okay, where should I show? Here?
Sure. You want me to tilt down? Whoop. Now. Yeah. So this is the platform. You can just show them the ends. That's what we're going to work with. This part. We're attaching this part right here. We have to secure some brackets to it. So we have to do the 2 silver brackets. And it's going to go right below here. And this is where the vat of resin is going to go. Is right about here. And there's a motor that will control that. It's separate motor from this one. Yeah, it's all in there. So those are the brackets, and this is the motor. This is the motor that's gonna go under here and then lift this plate up and down. I'm gonna change views because it's kind of shaky right now.
Yeah.
So I'm gonna transition to this one. We'll come back to the close-up in a minute when we need it.
Oh my goodness, these are in there.
I haven't looked at chat in a minute. So what are you building right now, Tim?
So these are the silver colored brackets. These are going to go, and basically I believe they go somewhere like this.
Tom responded to you. I think they go in
this side. This one apparently has so it's got a 70 micron laser, and it runs off G-code, and it uses a laser galvanometer. So it basically aims that.
Yeah, your face is like right.
Aims that laser.
Printer.
It's the broadside of a barn. It aims that laser, and versus some of the other printers of this style that are maybe a little faster, where they use an entire projector basically. So one layer projects at a time. The new Prusa SL1 was one of those types. I think it has about half the vertical or the y-axis build envelope as this one. And I think those are faster. So the Prusa can print like 6 seconds per layer. This one probably takes a little longer, and it depends on the size of the printer. So Tom, I know you're used to running machines. So, you know, your build rates built based on how fast your machine can move in the X, Y, and Z axis. You know, same thing with this one.
I'm going to tighten this a little bit because this is what we're attaching it to, and these are spinning.
Okay.
So you're going to put these on, I think, loosely.
Yep. Let me clean that shaft
because
off.
We're going to, since...
Remember one of those wipes?
Here. We put this directly in front of our faces. So...
We can move to the side.
You want to move this?
We can. I don't know.
I'll move it just over here for a second. Don't crush the wires. So this has to line up with this. So this part right here is going to go below it, and this hole is for the riser motor. And this little part, this little latchy part right there, attaches to that riser motor. So once this is installed, we're going to shift this left and right to make sure that those two line up. And oh, sorry. There you go. So it can actually lift up the vat.
Just double checking all fasteners.
It's a good idea. So how long can the resin stay? How long can the resin stay inside the printer? I just feel very close right now.
I hear it's like a couple of weeks, but I don't plan on doing that. I think I'm going to get like a container just for the used or the leftover resin and just pour it into that and keep it, you know, clean of dust and everything else.
So once you print it, then you got to do stuff to it, right? It's not just like, it's not like the filament printers when you print it, you're done.
Yes, so the UV cured resins, I think most of them require an additional curing step. So you clean it off after you print it, and then you have to cure it later. So cure it later, and you can use an UV light. If you're in a bright and sunny place, you can just stick it outside for a couple of hours. I think maybe a couple of days.
It's winter here, so no.
I don't really want to go outside and put the part out there.
Especially not when you have dogs. They would probably just
eat it. Yeah. So we'll get a light and use the light to cure the parts. They have LED strip lights. You can get a like one of those one of the other lights that are just like the floodlights. Again, this part has those press fit inserts for the nuts and that are on here. I don't know if you can see any. And there's springs, it looks like.
Why does it have springs?
Not sure. I think the back goes in this.
Yeah.
Maybe that's to
lock it in place.
In case maybe the build platform comes down too far. You don't want to break your vat. So maybe that'll keep that from happening.
Because all there is just that IR sensor as your stop.
Yeah. Like
for the other printers we have, they use limit switches. So when you're going up or down or on the other axes, when the plate gets too close, it triggers a limit switch and knows to stop. Do you have limit switches on your CNC mill? No? Okay.
We don't have that yet. I don't have it installed yet. I do have limit switches.
I know you have them. I didn't know if you actually put them in.
I mean, the real one has sensors.
The Haas.
But we have to get that working first. And by working, I mean I have to replace the linear guide on it. Alright,
so we're ready to put this in now? No, you just cleaned everything off. You didn't.
I did, yeah. We have to have a clean work surface in there. Or our parts, or they're interfacing here.
When I joined the robotics team, everyone else knew each other. I was new to the state. And I was like, who's that guy that's always cleaning it up all the time? And I was talking to Rose about you. It's like every time I see him, he's got a vacuum or a broom.
The kids didn't clean it.
Kids are messy.
All right, how do we install it? Put the screw head on the outside. We're supposed to get those M5s.
What? I'm sorry.
The M5s.
Oh yeah, I'll get them out.
27s.
Okay.
I want to know if this screw head goes on the outside or the inside. Does it say?
I'm gonna let you try and figure that out while I get you the M27s from my box of hardware.
I'm just gonna go with it like.
You said on a Haas?
Yeah. I have a TM1 circa 2004.
That was an interesting machine to move.
Yeah, they have those drop deck trailers.
He said we had to replace the XY guides.
I remember that. That was quite the experience or issue you had, I think, if I remember right. That was a long process, wasn't it, Tom?
Anyone in the chat, you should also check out Tom Zeltman's channel. He does Saturday stuff sometimes too.
Doesn't fit.
Wrong one. Wrong. Find the right one? So we haven't done the Haas yet. That's on our list of to-dos. So we have the CNC mill, the lathe, the Haas, and now...
Which is also a CNC mill. I have a CNC converted benchtop mill that I first got into.
Tim...
These things spiral out of control.
Tim was like, I'm getting a machine that needs floppy disks. Do you have any floppy disks? And I did, because my university had machines that also only operated on floppy disks. So I had them back from school. Old, well-calibrated machines.
Is this supposed to, like, cinch down on this?
A little. I think you tighten it up more later. I feel like I've been looking at this box for 5 minutes. Keep forgetting which ones.
I'm, like, terrified of this. Like, it, Getting there.
Close.
Yeah, there we go.
Any
Probably
other
have to loosen that up, though.
good
So
machine stories, Tim?
Any machining stories? We made a couple parts. I actually... we need more time, right? To do all these projects.
We're going to show you the lathe video soon. I did this thing where... that I do sometimes, where I start a video and then I get an idea about how I need to explain something more, and I made an animated version of a lathe to try and show what the internals look like. If you like lathes, you should check out Tubal Cain. I watched his videos to figure out what the backside of the saddle looks like.
Mr. Pete 222.
Oh, thank you.
But
if you type in Tubal Cain, maybe you don't get it. I don't know.
Okay, now we need to insert this with.
You said I needed 27s.
M5 27 screws to secure. Oh, we didn't install this yet, so we got to install this.
I can't find them.
Oh, they're probably not labeled. There was a pack that was not labeled.
Oh.
And they were really oily. I think you took them out.
I'll look back here. So, yes, sorry. We're going to have a lathe video that comes out soon that is the first time that I used the lathe, and I tried to just make a bolt. It took longer than expected. Partly due to that backlash issue we were talking about earlier.
There was a package of screws that was here, and I know it was here because I totally took it out.
You want to look behind the tablet?
Oh no, our printer build is ended.
Lost.
How did
we do this?
How did I do that?
It's a very good
I'm
question.
assuming there was that. That's not it. Oh, here it is. Haha. Okay. Yes, these are it because there's 4 or 5 of them, and there are 5 nuts. Okay.
Good job.
It's amazing how they were right in front of me. Can you open this?
Yep.
There we go. Put these out. These look really greasy though. Oily.
There we go.
Okay.
Are we building anything this holiday? I think this might be the first holiday in a few years that we're not building something.
Yeah.
Was last year the...
I mean, we say we're not going to build anything. I think we're going to build a robot.
I think... Oh, that's true. You have the robot. I think last year we built the Eclipse stuff, right?
Was it last year we did the Eclipse stuff?
2017? No, that was after the Eclipse.
No. What did we do last year? Oh, we did. We did Alexa.
Oh, yeah.
We've
done some IoT projects that we haven't released. We have so many videos we haven't released. I actually finished one last night for you guys that will probably come out Monday or Tuesday. It's the first real video of our... You want this back? It's the first real video of our Twitter Drives robot series. We installed the operating system on the Raspberry Pi Zero.
I think that was funny. While we were doing that, we tweeted we did it, and what did we said? We mentioned something, and someone's like, "Oh yeah, you don't need to do this," and then they went ahead and so we actually figured out how to put
2 parts.
All of the Python libraries onto the board because I didn't. We both are noobs at this.
So the video that's coming out is how to put the operating system onto a Raspberry Pi. All the projects we've done with you guys in the past use microcontrollers, which is just a single board that has a chip on it, and that chip is... I'm going to move this whole thing over for you. That chip is broken out so you can program it and just use the same program over and over again. Raspberry Pis are a miniature computer, so they're a different ball game. So we have to install operating system on it, and then for our motor drivers for the robot, we wanted to use the Feather motor driver, and that uses CircuitPython, which is very nice. So CircuitPython is for actually boards that are more like microcontrollers, because Python is an interpreted language, which means it's a higher level. When you're using the Arduino code, the C, it just pretty much translates basically from C into machine language, right? Assembly language?
Assembly, machine code.
It translates it directly to the chip, so it's pretty lightweight for the chips that we're using, because they don't have a lot of memory, as I found out when we did our Alexa project. I kept crashing everything because we ran out of storage space. So CircuitPython is used for boards like that, for more Arduino-like boards, because Python itself is a higher up language and takes up a lot more storage. And CircuitPython or MicroPython is a lighter version of that. And MicroPython, somebody wrote just for embedded systems. And CircuitPython is a flavor that Adafruit created for their boards. So it's a lot easier. Their motor controller, their Feather, uses CircuitPython, and you just put in like motor1.throttle and then any number from -1 to 1. So negative 100% power to positive 100% power. So it's a lot. What can I do to help?
That way.
Move this way?
That's perfect.
So it's a lot lighter. So the Pi doesn't need CircuitPython, but the board we're talking to, the Feather motor driver, does. So we're having issues getting CircuitPython onto the Raspberry Pi, since typically it's not used. You just use regular Python. Larger?
Hex.
Okay. And what Tim was saying, here you go. What Tim was saying was we couldn't figure out how to do it. It wasn't installing right. And it was just we had put it in the wrong directory. It took us half a day to figure that out.
Don't tell them how long it took us to figure that out.
Well,
it was a eureka moment for sure.
It didn't. I gave up and went to eat lunch, and then came back down, and Tim had moved it to the proper place.
It took me a while to figure it out, and then I felt like, oh wow, it was about reading the instructions and not realizing that they were talking about different operating system for when they're talking about the Python root directory versus your operating system root
Correct.
directory.
So we kept putting in an operating system because for other projects we had to put things in that. Do you need me to hold it? I have smaller fingers.
Yeah, you can use this tool too. If you want to, you can push the screw right here.
Okay. Yeah. So in other projects we had.
Oh. We can just rotate that out of the way.
I just got it started. we had to put stuff in the root directory, so that's why we got confused. And when
tool, my hand, please.
And we said something on Twitter, the guy that runs the library created a pip version, and pip is just something that will pretty much automatically install it in the right place. Pip 3 puts it in the Python folder. So we fixed something with our
we did
incompetence.
Kind of added a community contribution there through someone else. So thank you to them. But that's kind of cool. That's how the open source community works. It's really nice. People are out there that help out others who don't know how to code as well,
But we're trying to share more of that stuff too in the videos. Like the one that's coming out early next week, I talk about how I burned my finger on an SD card when I tried to install the OS for the Raspberry Pi. I guess that wasn't incompetence. That was just
the SD
card
melting in your Mac.
Yeah, it was.
Like literally melted apart and then exposed the inside circuit board. The actual plastic part just kind of
yeah. It wasn't a fun time.
So is this printer open source?
This one?
It's open resin. I don't know if it's fully open source. It might be open source. I forget.
I read the instructions. I didn't read the behind the scenes stuff.
But this printer does run on Cura. It has an open source tool chain.
It looks like you have more, like, since it's resin, it definitely has more interesting prints, like more glowy looking. If that makes sense. Does that make sense?
Yeah, more translucent, and you can light them up. Yeah, but this is an open resin, meaning you can print any resin that you put in here. It's UV curable. Where some might have like a limitation where they only work with like their specific resin, and that kind of locks you out from different opportunities. So I think I could probably go and get some different brands that I've seen. Like Form is one of the, I wouldn't say like one of the larger ones. They're more one of the larger desktop ones that are kind of affordable for like maybe a really high-end prosumer or a small business. There's one at my workplace, for instance, that somebody has, but they have some really cool flexible material that I haven't been able to find elsewhere, and I really want to try something. It's almost like a silicon boot. Where's like one of these flexible bands like this. You can actually 3D print this out of a resin, and there's all sorts of things that we could make that for the experiments that we do that I think we'd be able to utilize that with.
David says reading instructions, especially for Linuxy things, can be hard. It's true. We're new to this kind of stuff, and Chase says open source for the win.
If I plug this
we
in,
love open source.
Oh, has to be plugged in.
Oh, here. No. I brought this over.
Okay.
Instructions are dying. And we can show you guys the instructions if you want. I did make the slideshow available on the screen.
320.
So now we're installing the part that attaches the riser motor. I'm guessing it's going to go this way, right?
Goes with the, I think that might be upside down.
That's possible. That looks like it would fit better.
Yeah, like that. So do the front two first. Secure it between front and back frame near the right side.
So we're going to go this way.
Insert top two screws first.
Yeah. And then the motor goes in right here.
Okay,
I don't know if this top view is the best view.
Yeah, we should probably switch up where we have the camera
one?
maybe.
How about you hold this for a second?
We'll get this stuff.
And I'll just do this. Oh, you want to start that?
Yeah, I'll start it.
Okay.
Gravity works today, guys. Just, you have to do your daily check.
And then this one?
I think it's in the right hole.
Do you need to move it?
This is a pretty easy build so far. Nothing too complex. I think the calibration is probably what's going to be the more difficult
And we're not going to do that today.
part of it, but that's going to be a separate
up here.
thing that I do. And there's a lot of these printers out now that are cheaper. This was a more expensive printer, but there's some around the $400 price range, like the Anycubic Photon. That's a projector type, so it uses a whole layer exposure at a time, and it has a I think it's a 2K resolution, 2.5K, something around that. So that's 25. I think it was like 2560 by 1440 pixels, and that's exposed over the area of the print bed. Whereas this one's a 70 micron laser at 70 micron 70 micron spot size. So imagine a 70 micron pixel, and however many you can fit of those on the print area. That's the resolution of this printer.
Is that a better or worse view?
Yeah, and you guys feel free to comment on the views. If you want to see something better, just let us know.
Oh no, it's auto-focusing. Hopefully it turned off. Okay.
So the motor is going to go.
The bed right here. The motor is going to go down in here. The little riser motor.
Okay, so are we supposed to tighten everything up?
Some point.
Okay, we'll keep these a little. These are
You
snug.
can
Everything's
see
gonna be
my
snug for now.
Piping hot coffee.
Is it a bagpipe?
It is a bagpipe.
Is the bagpiper wearing a kilt?
Yes.
Okay.
This is not how I would have stored wires.
Negative. So sometimes you get wires that are in and it doesn't go by our aerospace standards, so we like to lament about them. Like this is a loose wire. This would, you know,
So this
ship.
is the.
Like,
I already unwrapped it, but this is the riser motor that we're going to be installing. I'm
gonna knock that one light down.
It's too bright. So, you need.
Oh, okay.
Did you fix it or break it?
I didn't do anything.
Is that better?
It's fine. Yes, I think that's better.
Hopefully, it's less
We're
blinding
in a prison.
for people watching.
Okay, so next step is going to be attach this. There are a couple little, they look like
There you go.
intake gaskets for a turbo or like an exhaust flange.
I'm going to move, I think.
These little pieces. These are going to mount.
I'm going to move you guys.
Somewhere.
Other side. They're going to mount on the underside of this.
Yeah. So the 3, and then the 2.
Oh. Can you transition back? Just hit the transition button. There we go. Well, I'll move this.
Oh, four holes. Okay, so this goes like so. Like that.
Do you think that's a better view?
Yeah, that's okay.
Now you get to see the other printer in the background. But this is, the motor's going through this hole, and it's going to attach, it's going to attach to this.
Is the autofocus on?
I turned it off, but we'll see what it does. Okay, let's go.
Okay, so I have
The bracket.
this in 2 brackets, and a wire gets
You're this
squished
one.
in between.
You're looking at the wrong camera view.
Yeah, I'm from the right side.
Okay.
I looked over there and it dropped down. Okay, so the next slide has us building
So
M325s.
Yep. It's me. And then you're going to attach it to the...
I got 2 or 4. 2?
Looks like 3.
3?
But that doesn't make sense.
There's only 3 left, so if that's right.
Maybe it's just 3 in the bag.
I see 2 holes, though.
Oh, and you're going to... It's... no, because that's already in there. We'll find out. So what got you into machining and 3D printing and stuff, Tim?
In college, I got access to essentially what was a maker space for the college, and I got to use a Bridgeport mill and a lathe to do some projects for a grad student, and I found that really fun. I wasn't really allowed to use the machine shop I was using, but I kind of was allowed to. Pretended to be a grad student, but I got in there. Got to use a nice lathe. But I did a project. We were doing a experiment for sound mitigation or sound a noise attenuation on an industrial cooler, like one of the big HVAC units that have a fan, and they run it through the heat exchanger, and they wanted to know if we could make something that could go around the fan blade and make it quieter.
No, you're right.
I don't know if I'm doing this right. So what I did was help build an enclosure for this test setup, put microphones all around the lab, and we weren't really able to get a positive result. I think we had one time where I actually saw a reduction in noise
It's upside down.
for this test. Yeah, I'm upside down. Goes like this. Sorry, we're looking at these instructions and trying to read them. So that go by the picture.
So that part is going to attach in there.
Big white part should go through the top. Yeah, and then these should be on the bottom.
Okay.
So I don't know why this one has like 4 screw holes in it.
I don't know. I didn't design it.
Engineering change probably happened. Okay, so this is going to go through like this.
Yeah. Sorry for interrupting your story.
Yeah, so it was cool. I got to do some testing, look at how to measure using some of the scientific equipment, the data acquisition equipment, rather. And also see that you can do a lot of testing and stuff and have no success with an experiment. So that was pretty cool to see. I got experience in the machine shop too at the school, doing some work on our the Mars Society rover, or Mars rover that we were working on to go out to Utah and test with, and that spawned into me now being a judge for the University Rover Challenge, which is held every year out in Utah, and we do a Mars analog competition where teams from around the world come out and they build a rover and go through our insane challenges. And we try to make it really, really hard for them to do it, but they do pretty well. So I don't know. We try every year to get harder and harder. And this last year we introduced one of the sponsors, a company called Protocase out of Canada. They do a lot of sheet metal work.
They do work for SpaceX.
Yeah, they do work for SpaceX, Boeing,
because they
everybody.
have quick turnaround times, right? Like you send them something and they'll send you something back within like a couple days.
It's like a 3-day turnaround time, which is insane. And but you're gonna pay for it, but they have a great turnaround time. They have an online tool. You could do like this bracket here, it's this sheet metal, it's all bent up. You can do a lot of powder coating, laser marking, or print, multicolor printing on top of that if you need like labeling. and they ship it anywhere around the world pretty quick. But they built a lander for us, so it was a really cool thing. And I do a lot of the equipment servicing and autonomous traversal tasks for that challenge. And they have a drawer that the rover has to pull out, and the rovers have to put a container inside that drawer. There's a captive fastener that they have to grab, like a hex wrench or a screwdriver, and rotate and tighten and loosen the latch that's on it. There's another panel that has like a Southco, real nice, heavy duty. It's almost like a freezer door latch, so it pulls it out, and they have to open the door. And inside there's my task, which was a computer interface with a Raspberry Pi, with running a script that populates text on a e-paper display. They have to go through each of the steps there in order to complete that part of the challenge. And so that was really cool.
I'm gonna recap what you said.
Yeah.
I wasn't really listening. I was reading instructions. But he has they have a metal thing that looks like a lander, and the e-paper display tells the kids or the students, they're not kids, they're college students, tells them what their rover should do. So their rover, they control it from inside a U-Haul, and they have to flip switches to turn on LEDs at certain times. So the paperwhite display tells them which ones to turn on, and it says things like armed and danger and launch and stuff and flashes. And I think they did pretty good, right?
Mm-hmm. Yeah, they do. It's always a different challenge every. It's pretty complicated.
And did you tell them about the autonomous traverse?
The autonomous traversal I did not get into. So that is a task that I really wanted to see for a long period of time, and we were able to do it 1 year. I think it's only been around for a few years now, but that is a multi-stage event, and each stage gets more difficult. We're trying to drive the use of computer vision. We're trying to drive the use of computer vision, different sensors, not just dead reckoning where you just count how many rotations you have on the wheel to know how far you went. So we want to use.
Sorry, did you do this part?
Combination of GPS
and turned it in.
Yeah. Okay. Combination of GPS and what do we have? Altitude barometer, whatever sensor they need. But we ideally use all computer vision, because they actually could drive the entire course with computer vision, knowing the GPS coordinates. So we kind of cheat because we have GPS. On Mars you would not have GPS, you might have you have Mars GPS. I don't think that a system like that exists right now, but with humans traveling to Mars whenever, that would be something hopefully we'd have. This is actually really...
So right now what they're supposed to do is look for tennis balls.
Yes, thank you.
So we as evil judges go out and find a place to put tennis balls that are like right near a bunch of rocks or off of the edge of a cliff or at the top of like a mountain, and they're supposed to drive around and use computer vision to look and find the green tennis ball sticking up in the desert and navigate to there. And when they get within a certain radius, Tim's the one running around, and he sees if they're close enough and radios back, and then I would tell them, yeah, you're good, go to the next waypoint. So that's the hope, is that they can create a rover that can use computer vision to go around. But the problem is you just don't want computer vision to only see the tennis ball. You need it to know rocks or things like that, because they get stuck on giant boulders or go off cliffs. So you can't just, book it towards a tennis ball. You have to be wary of your surroundings and put some machine learning and computer vision into that kind of stuff to know how to drive and how fast to go. So that's the hope that they'll do that. Right now, I think most of them use GPS.
Yeah, some do use sensors and some have done.
They're getting better year after year. What you looking for?
I need to tighten this now.
Okay.
A big one. Yeah, so last year we actually did have some really impressive teams. Only a few actually were able to get pretty far on the course. The first year we put it out, somebody beat it, much to my dismay. I mean, good for them for achieving that, but as a judge, I want no one to beat it. Because that means I don't have to make it harder next year much more than it already is. Or much harder. More difficult.
Unlike FRC robotics, these teams are allowed to use the same rover year after year after year so they can make it better and better. And what I love about... do you want me to switch it up? Oh, okay, you did.
I just moved it back. Sorry.
And what I love about these competitions are they're international. So you have teams competing from all over the world. So I think that's pretty cool that they all converge on Hanksville in Utah every year. And I think they triple the population of Hanksville when all the teams arrive.
So I'm supposed to center this piece
yeah.
you can see right here, but it's not exactly in center. It's still within the edges of the silver, the aluminum piece here, but I'm going to make it just a little bit better. I think what we could have had here was a 3D printed tool that you could put in as a spacer, and that way you would know if it was completely centered. Because what happens is if it's going to be all to the edge, it might not work as designed. I feel like
it's too much slop.
Okay.
And you have to
so I guess
tighten these down.
I guess that's probably as good as it's going to get right here. Oh, I see. This can kind of pivot a little bit too. So it's kind of a weird design, this in here. It's all fully threaded. I can feel it. It's a fully threaded fastener versus the shoulder bolt, where a shoulder bolt might be a better choice for there because it rides on instead of on a thread, it's going to ride on a cylinder. So that's something to look out for. I don't think it's going to be too big of a deal, but I may actually find a shoulder bolt and switch that out at some point.
I'm getting the parts for the next thing we're doing. We need some M36 screws and a metal hook.
I have a calibrated hand for my torque wrench. Torque fingers. Oh. Tom would know A-bomb torque, but we don't need that here.
It's tight quarters. We've pushed ourselves all the way back against the SciJoy desk. That's what we're doing next.
Oh, we turned off autofocus because these cameras are crazy at autofocusing on here. All right, so this is a little metal hook, and that goes into here.
I think so. I read these instructions and looked up stuff last week.
Oh, so this is kind of like a limiter.
Oh, okay.
So this might limit this. I guess if it is there a sensor that goes with this?
No, there are no more sensors.
Okay. So I wonder what this does, aside from maybe prevent this from flipping up too far if the thing goes crazy. I guess. Now there's also the other thing too is that you don't always need a sensor for positioning. Some of the newer 3D printers use these. The company's Trinamic, and they have a motor driver, and I'm sure there's others that are out there because they actually sense when the motor essentially hits something and it can't move anymore. It's going to create a electromotive force that you know, and you're also going to recognize that the current's going to spike too. So it can actually use that as a sensor in ways. So they use, I think on the Lowsbot Mini, they drive this all the way into the edge until it stops, and it sounds like your printer is braking, but it knows that it's hit the end of its travel, and they use that to set to 0. I still think it's kind of weird and it's unsettling, but it does work.
This is the back, that's the front.
I am doing this right, correct?
Sure.
All right, that's a healthy dose of approval. Affirmation.
Is it fitting?
This is good. What's that?
Does it fit? That's probably right.
I think it is. Is it turning? These are really long screws.
What'd you use?
What, the ones you gave me?
What did I give you?
M3 by 6.
Mm-hmm. I will get to that in a second.
Should have
M36?
M3 6?
Yep.
Okay.
2. And then we're going to install the bottom of this, and then we're going to get to the wiry bits part, which is exciting for me.
Yeah. There's only a few wires of this, though. It's not to...
You just plug them in, pretty much.
Yeah. Unlike others, there's a...
I do like that they've labeled everything for you. I think that's very nice. Unlike your CNC machine, they labeled their motors. We had to take apart Tim's mill to move it, and I was worried because nothing was labeled.
Oh, no. My wires are labeled. They're length cut, and there's only 3 of them, and they only go one way.
That's your label, is the length of them?
Yep.
Okay.
The x-axis is the longest one, and the y and z are the same. Ish. It's also so no one else can take it apart and put it back together again.
Oh, it's anti-theft?
Yeah.
So we're supposed to, sorry, I should show you guys what we're doing.
Yeah.
This is the bottom plate. Yeah, that's good. This is the bottom plate that we're going to install. There's a protrusion right here, and that's supposed to go to the front. And from the pictures, it looks like it's also from the opposite of, like, this side. So over here, and then we should screw them in to the front and to the back first because, well, we don't know if these left and rights are totally... Is it
autofocus?
I know, it says it's off. It might be
totally on.
It might be because we have 2 cameras, so it doesn't know which one's directing. Anyway, so we're gonna screw in the front and the back first, and then we'll see how well we did with left and right, and then that's when we adjust and tighten our left and right. And by we, I mean you, because this is your printer.
Okay. All right. So screw size.
You need M320s. You need 8 of them, 2 on each side.
No screws. Over there.
20s. That looks right? Protrusion over there, under this.
I think so. I think there was. These are where the electronic mount.
Yep.
In theory, it doesn't matter how we do it, but only the right way is going to actually screw in. If this screw goes through.
I don't think that's right.
You don't think it's in correctly?
No, I think it's in right. I don't think your statement was accurate.
No, these are evenly spaced. I should have brought my screwdriver. I did bring my screwdriver, didn't I?
Where's it?
What did I bring? Where's the...
I don't know.
I might not have brought it. But it might be.
That was quite the journey.
Where would I put it? Did I put it in the bag with the power supply? In the Galvo on the stairs?
Oh, look. Tom said something.
Oh, man, Tom. Hey, it's nothing like a build day, right? A build day for the community. What's up with your X-carve? I haven't been able to catch up if you posted it on your channel.
You're right.
I did bring it? Nice. Yep. Alright, we do have 2. I'm going to take this up. I don't think that...
Is that what you meant to do?
Yes, I don't... I'm having a hard time.
Getting it to fit?
Yeah, getting it.
Do you want to put it on its side?
No, I'm having a hard time with alignment. This is... somewhere. There we go. Can you put that screw in, please?
Yep.
Does it go in?
Yeah.
Okay. It is? Okay. Once you get it started, I'll go another one. we've upgraded to 2.
To what?
2 screwdrivers.
Oh.
These are really nice, these Weras. This came with my open beam printer. Don't.
What did I say to you?
Don't tighten it too much.
We're supposed to do the front and the back first.
Oh.
Goof. That's okay.
You did pinch this one though when you did that.
I'm undoing it.
You can just loosen up 1 second. There we go.
I'll leave you for
So we kept everything.
minute.
We kept everything loose to assemble it. So you can buy this printer pre-assembled too, but this is a little more fun, I think. I think if you were a business, you would totally buy it up and have it running from the start. You know why we do the front and back first?
Yes.
Because why?
Because we didn't tighten the left and right.
Yes. Did they know that?
Yeah.
We knew that.
Because I said it earlier.
Oh, okay.
It's okay. I think you were telling the story.
I'm telling a story. I totally missed out in the explanation.
Well, that's what happens in the live stream. You have to.
There we go.
You're being a good live streamer.
We'll tell you the story twice and explain it 4 times, just to make sure that you still don't get it after we're done. Alright, there we go. This is a lot nicer if you want to try this one.
Okay, thanks.
You have all the screws out. You need this one.
No.
Where is that other?
Can't tell if it's going in or not. I don't think it is.
Yeah, I'm trying to get this one to grab. Oh, it
There we go. Is yours going now?
should in a second. I just have to.
I want to jam you up. I'm going to stop.
Negative.
So what was easier, this printer or your...
This is easier by far. So my open beam Castle Pro, I got that on a Kickstarter. I think it took 2 years for them after I paid for it to be delivered, but it did come back. It was really high quality. I upgraded a little since, but it took a while to build. This one, I think, they've got documentation that's sufficient. There's a PowerPoint. It tells you everything that you need to know, for at least for my skill set, and I think it's been pretty painless so far. And I think
We'll find. I think the calibration is...
Yeah. Now, there's a couple things with printer that I think they should do differently. And then we can get into them. I don't know if you want to talk about them now, but there's the VAT. So the build VAT on this one uses a PDMS layer. I don't know what PDMS stands for, but apparently over time that builds up material on it, and then you need to replace it. There's another one that I think they should include standard in this. That's the FEP VAT, and that uses a film, and the film is easily replaceable. It's just inside a housing that slides in here, and the housing can be unscrewed. You take the film out, you put the new one in, you clean it or whatever, and I guess you squeeze it down to the surface. That allows you to fully reuse your material as well. And then the other one, apparently this has a little bit of tricky bed leveling. They have another bed leveling piece that goes on here. So that was probably something we would want to get pretty soon if this drives me crazy. So Chase said he has no experience with 3D printing. He said he backed a Tico Kickstarter that never ended up getting fulfilled and burned, but I need to try again. Yeah, definitely. And there's a couple good printers out right now. I don't think there's anything wrong with the little mono price, the $120 printer you can get. I think if you go on eBay, you can get the mono price. I forget which one it's called, but it's like the Mini, Monoprice Mini Select or something like that. My coworker has one of those. He likes it. He printed a flexible phone case after he made a little piece for his extruder. It took him about probably 10 hours to make something. Or rather, I printed a flexible phone case for him on my printer. Both of them are the Bowden style setup. So on the Taz over here, it's a direct drive. So basically where the filament comes into the hot end. Where that filament comes into the hot end, yeah, so.
I'm gonna wait, hold on.
Yeah, we're gonna transition.
Yeah, to the overhead, and then we'll transition back.
Okay.
You ready?
Just a second. Okay.
All right, there we go.
Okay, so on the Taz, oh, I didn't put that on there. Okay, so on the Taz here, this is a direct drive extruder. So this is where the filament gets driven, and then it goes into the melt chamber here, the hot end. So if we take this down below a little bit, there is a heater block down here, and this is where it melts and then it comes out. The style that I have and what that little Monoprice printer is the hot end's here, and then there's a tube that goes far away, and then the extruder that drives it somewhere over here, and it feeds that filament through.
That lets it be faster, right? Because it's lighter weight.
Yeah, in theory, your head can move faster and your prints go a little quicker. But if you engineer it to be able to move it faster with this setup, then it's kind of a moot point. So let's go transition back.
Oh, yeah.
We can show you more of the build.
So, I think this is on right. I don't know if you want to check since it's your printer. Make sure everything is nice and tight. And then we're going to put on the front plate.
So we're supposed to tighten these all the way down?
Oops. I broke off.
You decapitated the tripod.
I do that a lot.
I guess I didn't know that you could do that.
Yes.
So we actually want to tighten this?
Yes.
All the way?
That's up to you, I guess.
I mean, I would keep it loose until we're...
Okay, till we're all the way done?
Yeah, I'm going to snug it up, though. Oh, you already put the front and back in.
I put all of them in.
Okay. So if I was being super perfectionist, I'd put this on a granite surface plate. I take off the little bits, but that assumes everything else is perfect. So I guess it's not really that important, is it? There's a lot of factors when it goes to building things.
And they get calibrated and accurate. What's the new channel that we found? Machines, something with a T.
Tech Insider?
No.
Or
no.
Tech.
The one that showed the history of the lathe and precision and stuff. That one's a good one.
What was that?
They had a new one about micrometers, which is like one of Tim's favorite things. Micrometers and calipers.
Is it?
Didn't you want old-timey calipers?
I wanted a full set of, yeah. I wanted a set of calipers for different sizes, but that's, not calipers, sorry, micrometers. But those are for measuring thicknesses very accurately.
Then we're going to put on the front panel, and like we said before, this is where your little LCD screen's going in this little box, and then your power. What's this one? What's the little knob? LED to say it's on, I'm guessing?
Probably.
And I'm guessing this is your SD card slot. I skipped through some of the end of it, because we had to go somewhere.
Oh, Chase said something. I can't see what he said.
Oh. Maybe they found the channel.
Very cool. But yeah, that part there is next.
When I was going to get the thing, did you say Tom has an X-Carve?
Yeah, Tom's building he's rebuilding his X-Carve or fixing it.
How do you like your X-Carve? I thought about.
Jacqueline kind of wants an X-Carve.
Or a laser cutter. We're not getting it anytime soon, but those are my wish list next things.
She really wants a laser cutter. We approve of laser cutters, right? Because we're building a laser.
Left. This one shouldn't cut things. Maybe I can transition back. Ooh, we're tilted. Here, can you hold this? Thank you.
We're going for the artistic look. I think that's pretty cool. It's boring to be straight and level.
All right, that's close enough.
Okay.
All right, and this is what we're putting on next.
Oh, you can kind of see I was talking earlier about those fasteners that are press fit. You can kind of make out the right here.
The indents.
Yeah, so those are all these threaded inserts. They start at the hole, and then they put them in, and then they into the hole, and then they press them in to flatten it out there. And it's a very easy way to put a lot of fastening components onto a piece of sheet metal. Inexpensive, very efficient way to do it.
Oh, nice little carve out.
Yeah, that's nice. And everything, it's good. It's built up with some tolerance there. There's some stack up tolerance, clearance.
Tim approved.
Clearance, yeah.
Sorry if there's loud clanging noises.
It's Clanger Con. Okay,
Nope.
That should be sufficient.
There you go.
Yeah, and whenever you guys build something like this, you always, you don't always tighten the first screw down all the way. You want to get it in there, and then you work your way around. If you have like a circular hole pattern, you typically go in a star pattern where you do.
You can rotate the whole thing if you want.
Oh yeah. You change your tire, your wheel.
Sorry about the autofocus, guys. It only let us turn it off of one of the cameras. So I should probably look at what we're doing next.
Oh, where's my screwdriver? That's way better than this.
There you go.
Thanks. These are M3 fasteners. This is similar to the open beam. Is it the same size? This is. I think this may be Maisumi, or this is another, probably a Chinese generic brand aluminum extrusion that uses the same profile. But seems pretty good to me so far.
So it says after that you can organize the cables, and I'm gonna get you your next piece.
Just 4 screws?
Yep.
Oh, okay.
I think so.
I ran out of screws. 1, 2.
Oh no. Top and bottom.
Just 1 in the middle.
Yeah. It said 1 in the top and 1 in the bottom.
Okay.
Are you okay with tipping it, or do you want foam underneath of it?
No, we'll tip. This is a good anodize. Although right here is a
Just don't crush the wires.
piece of whoop.
Oh man, they're getting all the messy views of the bookcase and
No one's lab is organized.
all the stuff you see stacked up on the bookcase are things I don't want in the regular videos that I just throw under the bookcase. What's that noise?
This?
No.
I don't know.
So all those beads in the bookcase? It's just this.
Okay.
All the beads in the bookcase are from the machine learning series.
No, we're supposed to be tightening these pieces at the very end. So after we do all this.
I don't think it had that in specific of an instruction.
Okay, I'll use my best judgment then.
Now you can see another view of the riser motor.
Oh, I know why we did this. The acrylic panels.
Yeah. So the next thing we're going to do is the platform cover. What is a platform cover, Tim?
I'm not sure. What is the platform cover?
I don't know. I was literally asking.
I think the platform cover is the piece that goes up here and makes it look presentable to the end user, the operator, the owner. It probably also helps prevent spills from going down into the electronics bay, which is kind of an interesting way to do this too. You really don't want to spill anything, but I guess if you do have a spill, you don't want it to land on your parts underneath.
I do know that there's a cover for the laser, so you don't get any resin bits on it.
Oh, really?
Yeah, there's a...
I did this without any instructions. I hope this is right. Yep, so we're going to need to tweak this a little bit. So this piece here had some bend, a little bend, so we're just going to tweak that with our finger. Guessing it goes all the way to the back and down.
Yep.
Like that. Okay.
Yeah, you're lined up. You need
nice. That went in very well. So that fits up against the edges pretty nicely. That's a really good fit. Really good fit.
M36s. Do not over tighten these.
Yeah, M3s are, you know, they don't have the best. You know, you don't want to put too much torque on them. We'll leave it at that. Just gonna loosen these guys up while we tighten that.
And we use M3s a lot.
Yep, the open beam. So open beam, actually, I don't know if they're around anymore. To be honest, it's kind of sad because they had a good, high quality product. All those glass reinforced plastic panels and where do these go?
And I know there's 2 holes right there, and where are the other ones? This is secure to the right and left frame, 2 on each side. So.
Here's the camera.
Oh.
These are too short for that.
So I'm guessing, oh sorry, it was 2 M6s to the Z. So that's these ones right here.
These are.
I should have just given you 2. Those attached to the Z.
Yeah.
And then I need to give you different ones for the left and right.
Oh man. First catastrophe. From that on did take some of the paint off.
I'm going to move the light back a little bit.
So if you do install that, be careful what I did there. I didn't realize that it I took some of the material off the little scratch. So we'll just, you know, just
Is this better, Tim?
Nope. So I did scuff up the powder coat there a little bit. So no big deal. But if I were to do that again, I wouldn't have put that in the way I did.
Can you see if
Oh yeah, that's a lot better.
down?
Yeah, it looks great from the overhead view. Maybe we should transition over to that.
Okay.
Yeah, I think it does. Actually, it doesn't look too bad from. It does look a lot better. I don't know if anybody out there notices it, but it looks, that's way better lighting for this. The black powder coat shows up great.
It was looking like directly pretty much into the sun. What color should Tim paint his machines?
The color that they came in.
You had talked about for your mill possibly painting it a different color, like the stand.
Yeah, so the little PM30 that I have, I had thought about painting it like a gray for the base and then having an orange head. I think that's would have been a cool color. But right now it's all white, and it seems to be pretty good paint. So I think we'll keep it on there. Having a hard time with this one.
Alright. Do you need me to lift it?
It's okay. I just have to get it and start.
Oh, the heat's on now.
I don't think they can hear it.
Oh, with the Yeti you can. I'm well aware.
Where is that cloth, please? So these linear guides get pretty dirty sometimes, and so you need to clean them off. You should have them clean, but the blocks that are up here, these guide blocks right here, a lot of times they have integrated wipers that go around the profile of this rail, and as it goes up and down, it'll clean out this rail right here. This is where the the ball bearings ride inside these blocks. So these blocks have ball bearings, they ride in this channel, and then they rotate around, they kind of cycle around the inside of each of these blocks, and that's how it moves along. And this is a just a straight rod. There's no grease or anything on here, it looks like, and it's got a probably acetyl resin for the ball nut here, or the screw lead nut here. Probably can't see it. Maybe this view.
It's probably better. I don't know what's in the back half of the room.
Okay. So next up, we're going to put 4 M320s.
They're right there.
Into
the left and right side.
Left and right side. Okay, I'm on the left side already. Good.
Are you gonna take the stickers off when you're done?
I might actually leave them on.
In case you need to IKEA furniture this back together later?
Yeah, in case something has to go apart. But realistically, I think once this is together, the chassis doesn't need to be taken apart. But we'll look at maybe calibrating it and then seeing how calibration goes. And if it needs to be adjusted after that, then we'll have to take it apart, excuse me, and look into it.
Did you get this before Christmas so you can make everybody gifts?
Sure. I did think about
for your brother.
What kind of gifts I can make.
Because you're gonna possibly make D&D character kind of things for your brother, right?
Yeah, yeah. So I thought I'd make some.
He's probably hopefully not watching this.
Yeah. Different character figurines, stuff that's out there already. I'm not an animator for like a game modeler or any of the character modeling. You know, I know how to use software for CAD, but there's different kinds of designers that are out there, and I am not of that skill set. I do a lot of engineering designs. So,
what's your favorite thing that you've CAD'd?
The favorite thing that I've CAD'd is by far our 360 camera rig for the GoPros for the weather balloon, for the high altitude balloon.
Tom said something I think a while back. I don't know what question he answered with both.
What was both for? What were we talking about?
And the colors? I don't know.
Maybe gifts for that? Yeah, I don't know. Yeah, Tom, it does look. It looks like it's a pretty good kit. I'm pretty impressed so far. The powder coat's really good. This is definitely going to be strong. It's got some gravity to her, to quote a familiar YouTuber. I picked up the box and I was like, oh my goodness, what did I get into? Because my printer is actually made out of this, similar material to this. I don't have all the sheet metal pieces. The sheet metal pieces really add up, and then the acrylic on top of that adds a lot more weight. And I was actually really surprised at how much this box weighed. And it actually, I was having a issue picking it up because the box has it's slippery cardboard and tape, and there's no hand grabs on it. Hand grabs would be really useful on the box this came in. Tom said both the laser and the X-carb. So
good idea.
Yeah, I know. I've been talking with my dad about helping him build a maybe a 4 foot by 4 foot router table. So we'll see how that goes. That's probably something for 2 or 3 years from now. But we'll see how.
While I look up the next step, do you want to show off your?
Yeah, we can show off this thing because it's kind of.
I'm going to transition you real quick. I'm going to transition you guys so you can do the overhead.
Okay, so we're going to put this on the table.
It's okay if it's too much. Just so you could do that while I looked ahead.
Yeah, so this was the 360 rig that was going to be attached to.
Or you know what? How about we do this one?
The side camera.
This one.
Yeah, it looks so big. There we go. That's better.
Hold on.
So.
There we go.
Yeah, that's good. Can you pop the focus, please?
This no.
Okay. Oh, that's the webcam on the Mac. Okay, so this it's missing one side because it's actually removable. So I had built one side that could be taken off.
Which is the only part that I designed was the or told you to design was the
Oh,
removable bit.
design the removable bit. Yeah, 'cause we were like, how do we get all the cameras in here? So
I'm a maintenance engineer, pretty much.
yeah. And do we have that side, or is it?
Oh yeah, it's in pieces.
Oh, it's in pieces. Okay. So each of these pieces here, I took the same design really as one of these other side pieces, or sorry, one of these pieces. And I used Fusion 360 for this part. And so these corner pieces here, they were basically an adaptation of the pieces that are not apart. So like this corner, for instance, this edge here. And what I did was create it such that the one part, I basically copied it, and then I made it so we could attach the two halves together. And what I did is I took and made basically a line, plane, a couple planes through the part, and that was a slice that we used to split that part in two. And the fasteners here are those threaded inserts. So they're heat set inserts. Use a soldering iron and put them into the plastic, and then we put the fasteners in. So this side was held on. Probably had way more screws than was needed, but it was a cool pattern, so I kept it. Inside it has power provision, so we basically have the ability to put 2 battery packs in the center and power all the GoPros. There are going to be 6 GoPros around here, each at a different orientation as you go around the outside. And you'll see these fans in here too. So there's a lot of fans in here. What we had to do was on the ground, these guys kept overheating, and it was a hot day, so
GoPros.
some testing for the GoPro Hero sessions when they're in 4K especially. They are meant for action sports, and what we didn't realize that part of the action sport was the motion. So when you're surfboarding, you have water to help cool it. If you're on your bike or you're roller skating or something like that, the air movement over top helps cool that camera. But when we're sitting around on the ground or going somewhere not fast at all, they overheat and it shut down. So we didn't want that to happen, and put these heat sinks and then fans to help cool them while it's on the ground. We could have put some logic in to turn off the fans, because they do this does use about 1 watt of power total for all these fans, and that does add up when you're trying to fly. So we could have put logic in, but we didn't really have an idea where we need to cut that off.
It was the night before we were supposed to leave, and it was what, probably 2-3 a.m. Did you tell him this already?
No, I didn't tell him this part.
And the batteries shorted out the GoPro.
Oh yeah, I forgot about that.
I didn't.
We we could have got a new one. We weren't sure what happened with the GoPro. It wouldn't turn on.
It was the battery management thing, and we resoldered
We had a short on one of these. Okay, yeah. So one of these. So we actually made a board here. This is a custom circuit board, and it's got a. I don't know if I can pull it off.
We're gonna get back to the printer in 1 second.
Yeah. So we actually have wires coming in from the battery. They go into the board. There's a voltage regulator, and it goes to USB-C, and that went to a cable that goes to the GoPro to power it. And there was a short on one of the boards, and we had to solder it somehow.
And we had to
and fix it.
Tim wanted to be conformally coated, pretty much, right? So we put hot glue on everything. So then we had to unconformal coat it to fix it. But this is what we're doing now, Tim. We're putting, well, it says.
Back to this.
Actually, it says make sure the platform is centered and it's not rubbing against the platform cover, and you can still adjust the platform by loosening the screws and moving the silver colored brackets on each end. So after you check that, we're going to add the motor drivers for the galvanometer. And there's one for the X and there's one for the Y. So,
oh yeah, Tom. Good point. Yeah, sometimes, especially like if you're in a business and you're making products, buying a known solution for a system is usually the one you want to go with. Like X-Carve is a great little kit. It works. There's some good,
I would buy that instead of making my own.
Yeah. And definitely some lasers out there that are probably better than others. Like one of the kit ones you can get for like what, $200 now. Probably not the best idea to use because it might catch your house on fire. I don't know, but
Sometimes we like to build things like this kit, and sometimes I just like to make things with the tool instead of making the tool.
Yeah, so I could have made a printer, but instead we got a Taz.
Yeah.
So that's an example there, which has been great, by the way.
Love it.
Jacqueline loves it. It works every time.
Pretty much.
I think it has a very good success rate. I think only a few times I've had some
Tim
issues,
mostly works on his printer, and I print.
Yeah. My printer is kind of a project.
All right, I'm gonna switch camera views again so you can see. I might tilt this down a little bit more.
Okay, so we're putting boards in. Do we need ESD protection?
It didn't say so. I'm transitioning.
I think we do.
Just
it
to
is
let
a winter time. Let's go ahead and
okay, you can get the mat.
grab a. I don't know if we need a mat. I just need to ground myself.
There's wrist straps.
Yep.
So while he does that, these are the boards we're going to be installing. These are the motor drivers for the galvanometer. This moves the mirror, right? Correct?
Yes. So the mirror moves.
Right.
And
the laser stays still, and the mirror directs the lasers. And there's one for the...
I plugged this into the white wire, right?
I don't know if you can...
Or something.
Well, the sticker, you can't read it. But it says Y Galvo. And there's one for the X, and then these trim pots have been calibrated for each of the mirrors. And we're just gonna plug stuff into it over here after we connectorize it, after we put it onto the base right here.
These are supposed to plug to something that is grounded.
Correct. That's why I said it's not set up.
Oh, sorry. I didn't quite hear that part. Good idea, but
you can try and see if you can find something.
I'll just stick it in the wall. What could go wrong?
If the live stream ends, it's because Tim has electrocuted himself. You can find it.
We'll be okay.
I hope so, because I've been touching the boards.
My hair stick up?
So this is the X one.
All right, so we got motors, and we're going to put these in motor drivers. This is X1. This probably goes...
Is there a ground on that?
We're okay. We'll touch the out on the outside. Okay, where are we putting that? Right there?
No. Good try, though. Can you turn this... You might want to turn it so the right is facing you.
Okay. So it goes...
It says the X... It shows this picture where the right frame...
I'll take a look. Did you show these circuit boards?
A little.
Okay.
I didn't explain anything except for those.
They look pretty good.
The X is over here, and the Y is over here. And you're going to use M46s.
Do we do it like this, or we put it on the like that? Boards facing out. Like that.
Yep.
It actually looks like this. It kind of looks like this had been installed at some point too.
Well, didn't they calibrate it and test it out?
Oh, okay.
Right?
They have a rig.
Because they had to calibrate it for your particular printer, right? Yeah.
That's pretty cool.
Maybe I should move it closer. Hate moving them.
Oh,
yeah.
that one broke.
So,
I think it's funny you know more about a printer than I do.
There's a very good community of people.
That I do know. I did find some cool stuff. They have a document that they have on Google Drive that they have listed a lot of different resins. I don't know if it's all of them that have been tried, but many have been tried that are out there, and they put the different settings, you know, what their success was, and all sorts of speeds and feeds, I guess.
If we do this again, we'll light everything better. We've been traveling a lot, guys. We didn't have too much time to test this out, but Tim really wanted to build this with all of you. I'm going to find the next thing we're doing is the LCD panel, so I'm going to find that. What is... Did you tell him you're taking a class and this is why this happened?
Oh, yeah. I'm taking an additive manufacturing class. And it's been talking about different methods, some of the learning been about generative design, which is something that we have access to in Fusion 360. I don't know if Tom even looked into that at all. The generative design is where you basically have a set of constraints for a component that you want to build, and then you use the computer to design the actual component. So if you basically had some points, some holes that you needed to fasten to, and you knew you had like a pin somewhere else that you needed to add into your part, you could basically outline those and then tell the computer to generate the part within that volume and what material you want to use, and it will actually develop that entire shape.
So it tries to make the strongest, lightest weight, usually.
Yes, and it's designed. You can use it for the generative design is typically going to be a 3D printed, additively manufactured part, almost exclusively. Whereas there's another process called topology optimization, and I see that as you can take a component and you can remove material such that it will optimize the use of that material and give you the lightest. Maybe if your goal is for a lightweight part, maybe your aerospace application, you can start with a conventionally machined part that goes on a multi-axis CNC machine, router or whatever, and basically chip away at the material till you get to that optimal shape that may also be stronger than what you started off with, just by how the nature of the material properties work with the strength.
Is the generative design program you used open source?
So the one in the class is not. There is something out there that is open source, but it's not like one of the ones that you're going to be able to actually use in a commercial environment.
No, not commercial. We just thought about possibly doing that with you guys, where you give us requirements and we put it into the generative design program, and then whatever it spits out, we print it.
Yes, well, we can do that.
And then we'll see which one of you guys has the best requirements for what we want to do.
Yeah, the software wasn't open source. So, but we can definitely make a part at the end that we could put on, post it in Thingiverse or whatever.
I think Tom responded to you.
Yeah, okay.
Sorry, our tripod is in front of...
Yeah, Tom's got a good point. Yeah, I've actually not used it very much at all. I've watched the video. I have been so busy with my day job and everything else that this got here 2 weeks ago. This is when we actually started looking at it.
Should I take it off? It says
let's keep that on, and we'll squeeze the tap through. Okay, fine. Let me test it first. Does this go like this?
Yep. It's your printer, so I wasn't going to take it off.
Nope, it doesn't go like that. It goes like this. Okay, now we can take it off.
Okay. There you go.
Let's see if we can just...
What kind of chip is on the back?
The display driver?
Yeah.
Maybe I'll just do that. So on the back here, oh, what do you know? It's an ARM.
I know more.
I don't know what it is, though. It's a GD32F103. So it's probably an ARM32 board because that's what drives this whole printer.
Oh, okay.
And so this display board here on the back has the, that's...
Oh, yeah, I didn't show them.
That big quad pack in the center, that's the actual control, that's the primary control board, or the microcontroller for this entire printer. Right? There's no other controls.
Well, I mean, it looks like everything goes... There's a power board, but it looks like everything gets plugged into... If you show them this again. It looks... There's a lot of plugs in here. I think everything goes into this.
Yep.
Yeah. Power. Here you go.
All right. So install time.
You need 4 of these, probably. And then, yeah, it says the main board.
Yeah, we'll just take this out.
It's the main board. And then there's an SD card slot that goes with it.
What's kind of weird is how the screen's actually mounted. It's very loosely held in with some glue over here.
I'm glad it has an SD card slot. And the printers that we have, when we've tried to ever print anything off a USB, it has not gone well.
Right. My
like it drops connection, and then the print head doesn't know where to go. So there's just like all these little jerky movements from all the different layers.
Where's the other one?
I do have a printer question for you.
Printer questions. What do we got?
A lot of people talk about tilting the part so the layers are different.
Yes, because of anisotropic properties. That's what I learned.
So it's a strength thing?
Yes.
It's not to make it look prettier?
Well, it's both. So for this type printer, actually, the layers, if you print, are harder to discern if you print it at an angle as opposed to like
okay, because everyone kept talking about how these printers should be printed at an angle to make it look better. And
one of the other
I
things.
didn't know if there was another reason.
Well, for the fused filament fabrication method printer, so the FDM, or fused deposition modeling for Stratasys, the like the Lulzbot there, the Prusa that Tom has, those, when you print the layers, so each layer has what's called an anisotropic strength, so the material property, so it's strong in the layer, but not strong across the layers comparatively. So it's stronger in the layers than it is across the layers. So if you have a part,
it's just like a fiber part.
Yes. So if you have a part and you print and you want it to be strong in a certain direction, you should align that strength with your layer print orientation. So if you have a part where you want it to be strong in the X and Y axis, then you should, of the part, then you want to print it with that axis being in line with the bed.
Like, again, I'm going to relate this back to composites because I know it a little bit better. So, like, you would put the tensile force of a composite layer in the direction of your strongest force. And then you're saying you're doing the layers at different angles, and that's kind of like when you're using a composite and they use like a 30-degree weave and then a 60-degree weave and 90 and 0, that kind of thing.
Okay, I think that's right.
Probably just confused everyone more, but it made more sense to me. What are we doing next? We're gonna install. Ooh.
Board's not conformally coated.
Next.
Just noticed that.
We're gonna install the SD card reader. I think install the reader included.
So it's supposed to be tightened right here, right? There were how many screws on this? 1, 2, 3, 4, 5, 6. Just make sure I did it right. This one gets one.
Do you see something that says the number of screws? I don't know. It just said.
Yep, there's one there. I was making sure there's one here, and I want to tighten down and crack the PCB.
Yeah, don't do that.
Oh, they're very strong, actually. Surprisingly strong. Okay, SD card.
I think.
I would put the bracket on.
I think it's going to this.
Yes, I put that together first, and then I put the bracket in second. Okay, I need more.
It just says with the included metal plate.
Can you grab my water when you get a chance?
Yep. So you're gonna hook this to the metal plate and then plug it into the main board, and we'll have our SD card slot. We're almost done.
How does this work?
It says to the metal plate.
Oh, there's a standoff on the board. That's cool. That is really neat. So it has header pins right here, and these header pins go into the socket on that board. Now I'm curious. I wouldn't
I'm going to transition you guys to the overhead real quick. To the chat one real quick. And then I'm going to move the camera.
Yeah, so I don't know if we want to tighten this one down all the way. Let's see if we can get this in there.
Is this in your way? Come on. They can't see you yet. There you go.
I assume we want that loose while we do this to account for any of the misalignments. And then it takes these.
Nope.
Two M35s.
Yes, these are M35s. Nope. Yes. Yep. No.
Oh, it's on the back. Okay.
You got me confused too. So we're getting as far as the acrylic panels, and we'll put some of them on, right? But not all of them. And then Tim's gonna take it home and calibrate it. And we'll share in the community tab. We'll share whatever Tim prints. I guess your calibration print first, and then the first cool thing you print. You get the power board. I'm gonna guess it's this. Do you think this is the power board?
Yep, it has a power plug.
That's why I'm guessing it's the power board. Ooh, bag of wires. What's this? Is this your selector? This potentiometer? We are almost done. So this little piece of acrylic is what's going to cover the Galvo.
The galvanometer, I think is what it's called.
You don't like it called the Galvo, but that's what it is in all the instructions.
Well, in case they get curious on this live stream what it is, I believe it's called a galvanometer.
Yeah.
Okay.
I'm just opening all your boxes now and figuring out what we have left.
Okay, that's good. Now we put the power panel in base.
Your resin thing does not smell good.
There's resin in there?
No.
Oh.
I wanted to call it a resin bucket, but I knew that wasn't right.
Oh, the PDMS.
It's a tray. Yeah.
This is not acrylic entirely. Yeah, that's what smelled. That's the PDMS layer. It smells kind of like that resin. So there's actually it's an acrylic panel. Oh wow, that's totally washed out.
Oh yeah, on the side.
Yeah, this is the bat, but there's actually a film on the bottom of this, I believe.
Secure it.
It looks like at least.
So we're going to secure the power board and the control knob, which is just a potentiometer looking thing.
Oh no, it's an encoder.
Oh, a decoder.
A rotary encoder.
It's even better.
That's going to go like that.
I don't know, you're ahead of me. We're going to still use the 3M screws. This is where the power board goes. Over here, I think is the power board.
Yep. Which way does the plug face? Down? That would make it face down.
Okay. There aren't pictures of it installed. So, we'll make it up. I think I can click on a link to the Google Drive and find bigger pictures, but then we'll never get back to the instructions.
Okay.
So we have the power board left, the galvanometer, and then we wire everything up, and then we put the acrylic sides on.
Cool.
Tim likes switches, by the way. Switches and
buttons.
Yeah.
My two favorite things.
I think you just have like bags of switches.
Yeah, I have bags of switches that need to be utilized in projects.
Careful when you move them.
So with the class that I was taking, we learned a lot about the different processes, and this one, photopolymerization, is the general class of the UV cured resins, and a lot of high detail. There's the capability to do some injection mold dyes, actually, so we could use a high temperature resin compound to do a high detail injection mold for a limited number of parts. So we could make something for one of those hand actuated manual injection molding machines. I don't know if it would survive an industrial hydraulic automated machine. You know, it can produce several thousand parts a day or hour, but the possibility of doing like a limited run figurine or something that you just wanted to do a plastic part, you could also do a resin casting, I suppose, as well, like one of the different resins that are out there.
What's the Stratus one do?
The Stratus does lots of FDM printing, and they have Objet, the company I believe they bought, that does it's basically like an inkjet printer. It shoots
There's
out
lots of colors.
Yeah, it shoots out the material and cures it with a UV light that follows it as it prints.
I think that's the one that they used for the movie Coraline. So it was like stop motion, so they had to print like all the different. What are you looking for?
Screwdriver, please.
They had to print all the different facial expressions. So they have tons of them. And they wanted to make sure that the color gradient on everybody's faces were proper. So I think they used those printers. Everything snug?
We're going to make these go into alignment.
This is it. Dun, dun, dun. Now you get to put your laser in the printer.
Oh my.
Get it. Have a good view of it for them.
Do we need gloves or anything for handling the laser? Keep any.
We can. I got.
That's the power.
The power cord.
The other one, the end, just the laser.
I did bring gloves.
This one.
It's up to you. This is yours.
Yeah, so let's take this out first.
I do STEM outreach, so these are kids' medium gloves. Hopefully they fit your hands. My hands are tiny. Do you want 2 or 1? I'm gonna get smacked in the face. Oh! Did I remove some hair?
Yeah. Okay, so this is the laser item, and one of the cool things is the use of mirrors is really not something new. There was high-speed cameras, and they watched. If you ever seen the high-speed footage showing like a missile test or something, a rocket fire into a test.
Where do you want them to be?
You can just watch it over there. They actually used a mirror similar to this, and they would rotate it. Let's see if I don't think you can even see it inside here. There's a mirror and it rotates. So we're just going to keep that closed up because we're not supposed to touch anything in there. But effectively, here's looks like it's probably a rotary encoder. Part number HTX08914. Probably some sort of a rotary encoder there. Some sort of a rotor encoder here, both the same. So they rotate that mirror, or maybe that's the motor. Maybe that's a stepper motor of some sort.
Is this the laser?
The laser module's right here.
Okay.
On this edge here, that's the laser. So inside there it rotates, and that's how you move everything so fast. Because on the CNC machine or the router table, the milling head has to actually traverse the table, whereas this one just has to angle the light. The gloves don't work.
Too tight?
Yeah.
Oh, it says you have to remove the protective covering.
The plastic. Oh, the metal?
Yeah.
Okay, what do I have to do inside there? Oh, that's a shipping protector.
Yes.
Can we install it first?
How else would the laser get out?
Yes. You're right.
You just gotta trap the laser in the box.
It'll eat its way out eventually. I'm pretty sure.
That's why I was like, I don't understand how this works.
Well, let's take it. I don't think that we need to take it off just yet.
Okay.
I would almost have put that in
I think we're supposed to
before the motor.
We're supposed to plug something in. Do not touch the mirrors or the lasers. All cables have labels on them. Now we're 17.
Connect the wires maybe for the motors. So I need to put the M3 screws in.
Yeah.
Okay. I think we're going to go out of order.
It says first connect the power cables from the X and Y to the galvanometer. I think that's why they call it Galvo, so it's quicker to say.
So we need to put the wires from this to go to this.
Yeah.
So which one's X and which one's Y? Is this X?
No.
So this one's the X and that's the Y?
This is X. That's Y.
Yeah, but this is the Y.
Oh.
And that's the X.
Does it say
this
on
rotates this way. This rotates that way.
It also has, see this label right there? That should match up to, I believe, this over here. It didn't say that in the instructions. They just look like similar labels.
You are very smart.
Occasionally.
That is right. So this is X, and that's Y.
Okay.
Maybe our printer prints this way, X and Y. X is front
This is
to
your
back.
main power board. I'm just untangling them.
Yep. I'm going to start installing this into the base. So
There you go. You can play with a button.
Oh, these are nice. Okay. This is like the one, I got one of these on eBay, and it said metal switch.
Tim
and
has
I got it
lots
was
of opinions.
entirely plastic, and I was like thoroughly disappointed.
You have lots of opinions on
It was
buttons
also
and
$3.
detents
It was
and
$3 for a plastic switch. This one I think is metal. Yeah, unless they are really good at vapor deposition on the part, that
Y Galvo
metal on top of plastic.
data. Y Galvo power. Oh, did you want to screw it down first, or you want?
I'm gonna screw it down first with the 4 screws. There's one. It does use these, correct?
We didn't get to those steps yet.
I'm going to secure it. Then I'm going to put the power wires in it. Then I'm going to remove the cover.
Okay.
To me, that makes the most sense.
Okay. Yeah, M36s. Is that what you're using?
M3-6. That's what I have.
Those are 5s.
What did you have on the table?
Here's your 6s. Just probably was this.
Yeah. The 5s did work. I'm going to have good screw penetration though.
So there you go. You have that, and I will sort out your cables.
Alright. Anyone have any questions?
I should probably bring up the...
Something processed, so you... Oh, nope, that was the same one from before.
X. We have a control cable.
You guys interested in seeing us do any live CAD or design and building, coding, any of those things?
Coding, live code would probably be me, and live CAD would be you.
Yeah, but while we work on some projects.
I think live CADing with you would be more exciting.
Would it?
Mine is usually, this doesn't work, Google quickly. Or this doesn't work, and then 20 minutes later I figure out I didn't turn the internet on the Pi, and that's why I can't find it on the network. To be fair, it was the third Pi I was working with, and I had turned the internet on the other ones, and I just missed that step. Because I was like, of course the internet's on. I just used a Pi.
Okay, so now I need to get Y plugged into Y.
When we're done this, we can eat, right?
Yeah, we can definitely eat.
My stomach is growling. I don't know if everyone can hear that.
Oh.
Maybe this is why they told you to do it first. Do you want me to do it?
If you want to just... No, I got it.
Smaller.
I just had to wiggle it.
Can I take this off now?
Yeah, why do you have those on? Your hands have any, like, circulation left in them?
I have teeny tiny hands.
Those still look... Okay, maybe they're not that tiny. I mean, maybe the gloves aren't that tiny.
So, what have you plugged in so far?
I need the x-axis. I plugged in the Y.
This
okay, bend radius on the edge there. I would say it probably needs a little better bend radius, but... Power.
I appreciate that they're twisted together.
Lasers, twisted.
That was the power for the Y. I'm giving you all the Y things first.
Oh, I just wanted the X for the power. Because those don't go to this.
You want X power?
Yeah.
There you go.
Because the data doesn't go to the motor. Right? It goes to the board.
This didn't come with a wiring diagram. I think they just assume that you'll figure out how to plug it in.
Yeah. It seemed to be smartly wired, so everything has like a place. And one thing I would do differently is I would run this in like a nice little cable channel, and everything would be like...
Cable channel?
Oh, this is going to be like that.
It's okay.
It's the cheapest way to do it.
It's not. There's nothing moving down here.
It's also not flying.
Yeah,
we're used to flying things.
And there's nothing moving. It's not going to get tangled.
Yeah. Y goes to...
Y goes to Y.
Data. I have the data. Do you have the data?
Where's the... So we have a couple more cables to do, and then... then we have the door with a latch on it. Tom says CAD projects are usually fun. I might be a little skewed since I deal with software all day. I find it interesting to watch Tim CAD. I learn things.
It's entertaining.
You would have to talk while you CAD, though. Can you do that?
Yeah, I could probably talk while I CAD and go through my design philosophy. I make probably the hardest CAD jobs out of some of the simplest things, but I make my parts design, the files especially, I design them such that I can go in and use parameters everywhere. So not only to size it, but also the interfaces. So if we wanted to change the size of our robot from like a 50 millimeter width to like a 30 millimeter width, we could change some numbers. Let's just use Fusion right now. So Fusion 360, you can have a parameter table. And so I change those numbers, and it would also change all the interfaces that the part's made up to. And so you just change your inputs, and all of the parts would go to where you want them to be when you're done. And that's one of the best CAD skills that I've learned during my time doing design work. This is a Y Galvo, by the way.
Oh.
Is that different?
Zach and I don't CAD. I have CADed before, I don't know if Zach has done much. So we make little sketches and send them to Tim and say, make us this.
I'm just going to go into 2.
Oh, there.
I'm assuming this is
here.
where it goes.
I can click on. Do you want me to click on the reference things?
It only goes one way. Goes right here.
Okay. There are reference diagrams. They're on Google Drive.
Oh, okay. This is the next Galvo.
Oh, I think they're all Glavos.
These are just power, so they're just going into this as a power.
Because this says Y Galvo on the back.
This is also like shorter.
Oh, some of them are Glavos and some of them are Galvos.
So wiring probably needs to be cleaned up a little bit for me.
They said they sent zip ties.
Oh, okay. That's probably all right. We'll do that off camera.
You can use their boring zip ties, or I have neon yellow and blue and pink ones.
Oh, pink ones are perfect. They have a nice pink pallet jack at work. Hot pink and a pink tool cart.
You know it's coming then. You're not going to miss a pink tool cart. You want to tip up?
Aim you up just a little bit. Sorry, I didn't realize that was like that.
Do you want to? You can go on the other side. Here, hold on.
I can just rotate.
That's another thing we can do. That's better.
Control cable. Extra parts. Okay. I've wired this to that, that to this, this. Now I need to go to something. The 4-pin.
Oops.
We may need our drawings.
This doesn't have a pan.
Maybe that goes to there.
I didn't click on the drawings.
Or maybe this goes to here. Maybe it goes to here.
Maybe.
Or here.
Ooh, maybe this is charged. Have you figured it out yet?
No, we probably need to look at them.
Okay.
That off. It was never on.
So, you can talk for a minute and I'll look up the drawings.
Okay, so we've got some wiring done, but I was talking about how these are here. So this is probably going to be, you want to wire these guys together. They're running from the same source and they're the same voltage, so you don't have to worry about like interference too much. Typically, like these voltage wires, like if you're running a little higher voltage, like you might have a machine or something you're building, you might want to twist your voltage and your ground or your return. So your 28 volts or 24 volt DC line and your ground or your return for that, you would just twist them. Is that your experience, Jacqueline?
Yeah, we had pretty much all twisted paired wires because you're creating an electromagnetic field, and when you twist them together, the way they twist, it cancels each other out.
Yeah, cancel that out. And then like your data lines, you don't want to run with your power because
all of ours had metal. A lot of ours had metal shields around them.
And then there's a thing called overbraid, which is a lot of times you see the sheathing that goes over top of the wires, and that's designed to keep it, in this case, probably keep it from doing this, but also keep it together and protect it from other things that it may rub up against. Kind of a chafing protection. So this.
You gotta keep talking, Tim.
Yes. So, any questions about this? I might be a bit skewed since I do a software day. Oh, Tom. Keep reading the comments if they're brand new. So main board power, that I think can go in to the only spot that it fits in. So that's over here. And probably up here in the top. there. Oops. There we go. That's a good little run there. And I wonder if, like, so probably, I bet we have to, like, make sure all this stuff, all these wires don't go in front of the laser, or else we'll be casting weird shadows in the part all the time. Then it won't ever print our parts right.
Better than keeping it in its metal box.
Mm-hmm. And this looks like the control cable. This goes from here. I bet this goes to... This probably goes over to here, but I don't know for sure. I don't know if that's exactly right. That probably goes to that one. The key. The Galvo data. Now we can get these ones wired up. Forgot about this.
So what is the design philosophy behind the like holes for the resin release? I don't know how better to...
Oh, the drain holes?
Yeah, that's the word.
So the drain holes are really important because the resin is expensive, and a lot of your parts don't need to be solid, so you can actually make them because you don't need a lot of internal supports in some of them, as you would with the FDM parts. You will need supports, but it may not
so you don't have
the
like
same
the
type.
infill?
So you may not need an infill. You can still generate an infill, but the parts need to drain liquid out when they're done, because you have to be able to cure it too. And if it's full of liquid resin and it doesn't actually cure it with a laser, then you have to do it in post-processing. Otherwise you have like this toxic resin inside of your part.
But and
you can shake it around.
How would you that's why I couldn't do it. How would you cure it if it's inside though? Because the UV couldn't get to it, right?
You'd
so
have to
forever...
Yeah, it would take a while to cure it probably. And I imagine that you could do it as long as it was transmitted enough for the light to go through it.
I'm looking up the wiring diagrams.
I am not. So what are these? What are these for right here?
That wire diagram.
Oh, there's wire
Here
clips. There's wire clips that go in here.
Does this help you?
And stop sensor, Galvo data. That not in use. X and Y. Y is on the bottom. Yep. Did that control cable. So that's the control cable. Yep.
It's a picture with labels.
I guessed correctly. Because that's a key, and this is kind of a key. Okay. X, Y, Galvo power. I don't know if it matters, but that's hooked up to X. Y. So I'll just flip these. I think they're equivalent. But there are 3 wires, so I don't know what the third wire is. This one's X and this is Y. The Y goes
X
on the
is
top.
on the left. Yeah. Yep.
Okay, this is going to...
You need the other one?
Power from the other board. SD card, control cable.
So how big did
power switch cable.
How big do the drain holes have to be?
Drain holes have to be large enough that the resin can drain out of. And to do that, you can use, I guess you could do that in Mesh Mixer is the software.
Because I guess I don't know how like viscous the resin is.
Yeah, so and that's right, because you do need it to be, and I was giving you a kind of a tongue-in-cheek answer, because the surface tension of the resin would probably determine the minimum size hole you could have, right? If we couldn't drain it out. Like you can have a fine mesh screen hold water, even though there's holes in it. But that surface tension of the water keeps it from draining.
What was the printer that printed like one... It was like one droplet at a time. Do you know what I'm talking about? You had to... There's equations for like surface tension of the... There's that whole graph. That was surface tension versus viscosity.
I don't know. There's like an object that does like the droplet and then it cures it. Is that the one?
Yeah, it literally prints one drop of liquid at a time.
I think that's like how the object works.
Do you need the next board layout? So did you plug all this stuff in right?
Mm-hmm. Yes.
Okay. And then this one?
Y Galvo power, X Galvo power.
All right. And are we going to unveil the laser?
I feel like we have an extra cable somewhere.
Oh, you have to do the end stop, which is one that people commonly forget.
Because it's not in the picture. This wire I do not like because it's so loose. It's like so big and there's multiple wires.
To relax, Tim likes to crimp things.
I like to crimp things and make wire harnesses in my peacetime. Which is kind of entertaining, isn't it? Yeah, where's that one go? Where's this one go?
3 wiry bits left.
This one goes where?
I'm pulling it up.
Z-axis, I think it was.
Yes, the Z power motor is in the far right on the down and down.
Over here?
Yep, down.
Middle.
Yep.
That's the Z.
Z motor
What's the
power.
other one? PM motor.
What's PM?
The PWM motor.
Ah.
I guess this is called the twist motor, the tilt motor.
The
Okay.
rise motor. And then the end stop goes...
Oh, this one's cool. Look at this. This is the end stop connector. So these wires are put in here and they're pressed in and then they crimp into existing little tabs there. So this goes all the way up.
The end stop goes next to the power on the main board. There's, I think there's, ooh, sorry. There's, you can route it through there, I think. There's, on the back, what is, maybe they can see in the front camera. There's a little hole so you can run wires down the back of the Z-axis.
This should be all the way down there.
There we go. You might want to put it around here maybe, because see this, there's this right there. You don't want it to catch on that. It might be tight enough when you go to the board. It's to the left of the main power.
I think these are probably going to get zip tied up to these or something.
Yeah. We won't show you guys the zip tying
This goes
part.
where?
To the left of main power.
Which is?
Straight ahead. Where you are. Yep. And that is for the IR sensor, right?
Mm-hmm. Or the, yeah.
So now we do the boards and the panels and all that. Do you want to install any of that today or no?
Yeah, the next step is just to put the panels on. So I think we're gonna, we could put the panels on.
Just the front one?
Maybe the front and the sides. I think
The front with a door
we'll
lock?
keep that on,
For transportation purposes?
I guess, for now.
Well,
Until we're done. We should put a remove before flight tag on it. And then we'll know what to do.
if you're going to do that, that's when you have your neon colors. That's what we would do in the shuttle. Because sometimes people will forget stuff. Don't push too hard down on that. This is a cheap Target bench. We would have everything was neon pink and orange and green to make sure that we remembered to move it before flight. Because when they first made the space shuttle, they thought they were just going to turn everything around in like a week and fly it again. But it was really months in between. So it wasn't really made for maintenance, so we had to construct a lot of equipment to go inside of it so humans could crawl around and fix all the wiry bits and the plumbing and hydraulics and all that. So there's tons of support equipment inside the space shuttle.
I do want to point out some cool things on here, though.
Yeah.
Maybe we should build the door.
We can build whatever you want and then eat lunch.
But we also have these cable clamps. I think these go here.
Oh, that's good.
That looks like maybe that was an addition.
What's this for?
That's probably for the hinges.
Oh, that's good.
So there's a piece here. And these are... Pick up these hinges. I was wondering that box was so heavy. These hinges are so heavy.
At some point we install this too, right?
Yeah, I think... I bet this one is simple. So let's switch cameras to maybe the top.
We're going to do the front door.
Front door? Okay,
yep.
We have to install the front door. I think the only one that I didn't want to put on was the back, actually. Okay. So what I'm going to do is actually I have somebody who has access to a laser cutter, and then we'll take the acrylic and have them cut out a hole and put a I want to put a fume extractor on this to hook up to a carbon and maybe a HEPA filter box. Have to build that, but use that because the resin smells when it prints. I don't know how bad it smells and how sensitive we'll be to it, but you're not really supposed to drink or get it on you, so it is kind of toxic in many cases, but having an extractor will help alleviate the interior air quality from degrading. But these are some nice little door hinges. But these are heavy. These are solid castings, or injection molded. It looks like injection molded metal, maybe. Has little pin marks on the back here. So these are probably not designed for this printer. That would be an expensive way to do this.
Here you go. I'm not getting my smudgy hands on it.
I think we just take the inside off. Keep the outside.
Whatever you would like to do.
So, let's go ahead and get figure out which side needs to come off
edges
here.
Are Tim edges.
Yeah, they're chamfered. They're chamfered edges. I bet that's the inside, actually. Yeah.
Pretty soon, Tim's gonna have to wear his green laser protection glasses.
So if we take this off, we can put the panel on. Oops. Tim failed.
Oh, because you went out of order and installed the button?
Yeah.
Tim got too excited about buttons.
It's okay, it's not really torqued down.
See you later, Tom.
Thanks, Tom. See ya. Enjoy your X-Carve. Hopefully you got it up.
Say we put the front panel on and then that's probably good for today.
I would agree. So we're going to get the front panel on and then we'll be good for the day. I can't get the power button off.
Or maybe now.
I need something to push against it. Maybe
I
that.
have a crescent. And that bag on the floor, maybe? While Tim looks for this.
Just, can you hold that against it?
Yeah.
Please?
Against.
I'm going to rotate
this part?
This part.
So, before we go, we're going to install the front panel, and then I also want to show you just an overall look of the printer.
Get the crescent wrench.
It's on the floor next to you, I think. There's a whole bag of them. With the Allen wrenches?
I'm sorry. I'm not sure which one you're talking about.
Is this too small?
Yes. You know what's going to happen is by the time, I got it.
Oh, Tim. So to make sure that it's actually closed, it's too shiny. To make sure it's actually closed, there's a key latch.
And there should also be a limit switch that goes here as the door opens. It turns off the printer power to the
Apparently,
laser.
some people just use magnets instead of, they do a mod and they get rid of the lock. And they just have a magnet latch shut it.
Ah, okay. Okay, so let's go ahead and get the front panel on. Let's rotate this so we can maybe move the screen out. And I will get the acrylic sheeting off. Oh no.
What?
Just there. I don't know the right way to clean acrylic actually. Like to keep it clean and like remove fingerprints and stuff. Oh, we want gloves, don't we?
Here's the location of the front door.
Hey, one more.
There's a box.
Maybe we can put this on the back side when we install this.
Do you want foam?
Yeah, that would be good. Or cardboard, whatever. On top of the file. I think we're going to stand up now. We can't sit anymore.
Yeah. What's that?
That's the power
Oh, the
cable.
power. This must be lovely sounds.
We're doing pretty well on time. I think we mostly nailed our time target. About 4 hours. I probably want to, at some point, check these guys, but...
Probably just use the overhead.
Yeah, I thought we were switching over to the overhead.
There we go.
Overhead camera. Okay, so this panel is going to go on the front.
Move a little bit more towards them.
I'm going to keep this on the front.
Oh, it's so close to the microphone. It has to be such a terrible noise.
Although, I actually probably have to take that off anyway.
Do you have the M316 screws, or do you need them? Actually, I think they're on your side.
The M316s. Maybe not. It's unruined acrylic. It's so perfect and shiny. Really pretty. Probably doesn't show up that great on camera.
I'm going to try and turn the volume down a little bit. Just because...
Maybe if you mute it while I do this, and then we'll just get right back on it.
I'll just turn the volume
Oh no, there's a spec.
a little bit lower. Because you're doing it right next to the microphone. M316. There we go.
I probably want to be careful when I go to the edges here. They're thinner, but we'll see. I guess it also pulls up a lot easier up here too, so. Go around one of the corners.
Sorry. So close. One spot.
Yep.
Alright. So we're going to use 6 M316s.
Are they pan head screws. This is the kind of stuff we can do once we get a laser cutter.
See? Tom was right.
I feel like it's on something. Maybe it's just bent.
It just looks bowed.
That front panel.
Definitely bowed.
The acrylic is?
Yeah.
Okay, so the acrylic itself just needs to be pulled in with the screws. Yeah, so probably when they cut it, that's a lot of material out of here. And the internal stresses of the part, sorry, so when they cut it, the internal stresses caused by removing this piece probably caused it to want to bow.
I'll turn the volume back up.
Yeah, there you can kind of see it. So, no big deal. That's just something that's going to hopefully be taken out by the screws when we put them on.
I don't know where the correct one is. Might be on your side.
What needs to be? Yeah, and we're going to keep the outside on it for now. Looks kind of cool, actually. Like a wood bot.
Mm-hmm. I'm looking for the tool.
Oh, I brought one, I think, in my set.
You have a set?
I thought I brought 3 of them.
Oh, okay. We'll keep going. And keep talking.
So these are 6 screws.
Less and less.
6 screws here. And the tool to put those 6 screws in is probably located in my hand now. I'm glad I brought these. These are a really nice set of Weras. I do recommend them. They're on the pricey side for sure, but they have great dexterity for the handle and they have an excellent tip on them. And Jacqueline, one thing we forgot to do before we did this was tighten up these panels. So we're going to take one step back and redo this step. But we did a test fit.
Yeah.
And everything fit. So success. So we're going to have to bend this around and address the step that I missed.
I think we'll just put this acrylic on, the hinges, and the front door, and then probably call it a day.
We're going to call it a day when we have the front done, because that's where the light comes out anyway, right?
Oh, and I'll definitely, when Tim opens this all up, I know we didn't see the laser in this, because you probably want to transport it back with it on. You'll take a good picture of it. Or
we'll
video
put that on
of
Instagram.
It, and we'll put it on Instagram and also in the community tab.
Yeah, the community tab, pretty cool to have now.
This one you did tighten. Is this right for this? Nope.
This one.
Is it that one? It didn't seem to fit. There we go.
So we need to square these up. Are they good?
Good to go.
Good to go. Other side now. And I'm just going to flip it over. And that encoder will fit through the hole, hopefully. Yeah, once you build this up, it gets really strong. There you go. So we don't have the fear of it falling apart on us.
What are other good things to print with this, as opposed to your open beam?
Oh no.
Did strip?
So we ran into a little issue here, that the head of that has sunk below where it's supposed to be.
Yep.
There's a no-no moment where we have to figure out where it got out of alignment. Maybe do the one side. So what happened here is this one racked a little bit on us.
Oh, I thought they were.
Wait. This is.
Were they not tightened?
This wasn't tightened.
With the platform?
Tight to the platform. This shifted. The platform could have moved it. So we'll just have to unscrew this a little bit maybe. There it is. There we go. And we'll just re-tighten this back up. That was a close call.
I thought we were gonna just end the stream and be like, well, that was fun.
That was fun. We're gonna disassemble it and put it back together. Glad we kept the labels on. So that was neat. Okay. That was satisfying. Ka-chunk as it moved into place. Ooh, my fingers. Okay. This one up here now.
Good?
I think so. Tighten up all the other edges here.
So what, is there anything that we have that we could do a test to see how well the UV light gets through as opposed to other light?
I don't have my UV flashlight. You mean the acrylic?
Yeah. Yeah.
I mean, we could use a UV light. Do you have one?
No.
I don't have one. Maybe we post it on Instagram as well.
Why do you have a UV light?
I have a UV light that was, I guess I saw it and I was like, yeah, that's cool. And I bought it for only a few bucks. And I went out to the desert and found out that it was really good at finding trash after the URC event. Because college students don't necessarily do their best at cleaning up after themselves. So, unfortunately, I had some cleaning and found it picks up plastic bits really well. All of the zip ties and stuff that may be left behind, or they're not intentionally dropping them, but they may miss them in the fast nature of the competition. And that night, I was going around cleaning up trash and found that someone had told me that you can see scorpions. And I actually found a scorpion with my UV light. It was really cool. It was
That's
about
why I
the size
thought
of
you
a pin.
brought it there. Because Dom told us, if you guys remember from our snake videos, he told us to
That was
take...
a long time ago.
Yeah, he told us to take the UV light with us. He told me specifically to check my shoes for scorpions.
I never check my shoes for scorpions.
There was a rattlesnake in the hab, though. Chasing the mice.
How about that?
I did not.
And could have with a shovel. Unfortunately, it was a risk mitigation. Nearest hospital was an hour away, so yeah, I guess that was what they did.
I'm gonna try and decrease the rattling.
Well, cool. We're almost to the point where we put the hinge on. So what do we have to do with the hinge? Just put the backing plate
These
on
are
the acrylic?
Yep, these are the screws for it.
Let's see if this took out that.
The M512s are used, and you also need 25s. Look for the 25s.
This is a pretty good size. I mean, this is a decent. That's my arm. I don't know if you can see. Pretty good size printer there.
All right. So we used the M12. You used the 12s, right?
These ones, M3s. The other one says M5 by 12.
Yes, and now you need 5 by 25s for the door.
5 by 25s for the door. Right here. Countersunk. Looks like they give you extra screws, which is nice. These are big ones to miss too. Okay, so we put FH. Flathead. Not what we call them here. Flathead. Use 4 flathead M5 by 25 to secure the door on the panel. So
see, this one's 25, that one's 12.
These go into here, you're saying?
I believe so, yes.
This doesn't go on, this goes on here, not the door.
No.
This goes on the door. Okay. Hinges.
I guess I'll look for the door.
The door is on, in the box, maybe?
No, that's the, is it? No,
I put it down in the box.
What else do we have going on, Tim?
What else I have going on? Well, I think I want to do some robot design for the Twitter robot. That's going to be upcoming. We have a robot kind of designed, and I think we need to make sure that we have all our requirements figured out for what sensors we're going to attach to it, and we could go through that design and share that with everyone too.
So far we have the pie up and we have the motor driver code, and then two of the next big things are actually getting it to communicate with Twitter and being able to see with a camera. I haven't used cameras on the pies before, but I'm sure it's pretty easy.
15 millimeter?
15? For what?
The other screws.
Isn't it 12?
12.
So I'm in charge of programming it, and Tim's in charge of designing the robot's chassis, because that's CAD.
Yes. I think I did this backwards.
Oops.
No? I did it right. Use. Okay.
There's 4 M512s on the door and 4 M525s to secure the door onto the panel.
It just doesn't.
I'll hold this.
I think it's upside down.
Okay. Interesting. This is the back side. We might be done for the day. Is this the power and not?
What did we do?
No, because that goes there, and that's the SD slot. Is this not? It might be a different one. Did I not give you the right one?
I might have done
Or
the.
that's the hinge. Trying to logic.
Oh, oops. That's why.
What?
I forgot the spacer blocks. Okay, so I'm going to do this a little different. I'm actually going to build a door first and then put it on here.
There you go.
Probably best to keep the paper on the outside of the, if you guys build one, paper on the outside of the printer. Rattly bits.
Yeah, trying to make it less rattly near the microphone. So the Twitter robot, the reason we're doing that is we tried to do a YouTube robot before. You guys controlled a Lego robot using YouTube comments, and it was trying to draw a picture. However, we had an issue where YouTube thought people were robots themselves because they were typing in left, right, left, right, left, right, forward too many times, so everything would go to spam. So we can't use YouTube comments as a way to control a robot. And this time we're making a robot from scratch, and we're going to use tweets because it's not going to stop you from being able to tweet the directions that you want. And what we did before was you could have a whole sentence. It could say, please robot, please move to the right. And it's all right, and that it would just pull that out. So we're going to do the same thing where it just pulls out the first direction that it sees. But we're hoping that there are a bunch of people that are doing it all at once. It will be like Twitch
plays Pokemon?
Yeah. It's going to be like that. So it kind of aggregates everything and then makes a decision maybe like once a second and sees what most people have voted to do. And you guys will drive through a maze. So I haven't done the Twitter part yet. I've not really worked too much with Twitter. New things we had done that we haven't released are we worked with a lot of IoT projects. So I made a skill in Alexa, and I worked with Google Cloud Platform, and we worked with a thing called Helium, which talks between the Raspberry Pi and Google Cloud. What else have we done with that stuff? Pretty much we were trying to get data from sensors and send it to the cloud was what our goal was. We kind of wanted to write a program where you could program a robot with an Alexa skill. So that way kids could sit down and learn about coding, doing voice assistant. But didn't quite work out. Alexa's skills don't have a lot of flexibility. They're pretty rigid. So, I think this is pretty good for the day, Tim.
I do too.
I think we should maybe do an overview of the printer itself.
So let's put it up and we'll pretend it's complete. Okay. Then we'll flip to the forward camera and go through as if we're going to build a print, I guess. I need to get one more part that I know we need. There's a door handle, I think, but that's not required for this. We want to get.
I don't think the forward one. We'll pan this one. If you want it, can you turn this,
door
please?
handle goes there. Oh, it won't fit. I was going to show the bat and everything. Okay. Nice. That's cool.
Alright, so I'm going to transition to the close-up view.
Okay, so there's a couple parts that I need to find. First, Jacqueline, I need to find the switch dial. It might be over there.
I'm trying not to move. I'm holding the camera. So this is where the resin goes. This is why you have the springs to spring load it.
Maybe that's what it's. No. Oh, that's cool. So these are actually ball detents right here in these little things. So this resin vat, you'd load this in, push it in,
there's a detent right there, so it actually grabs it, and that keeps this from moving. That's really smart. I wouldn't even have thought of that at first. That's really nice. That's held in place. This goes up here.
This is the resin overflow line right there. What's the minimum amount of resin that you can have?
I don't know. Maybe a little layer, a couple layers worth.
Do you always start out with the same amount?
Well, it can't go above the resin overflow. I don't actually know that answer. I haven't researched that part a lot. I know that you need enough resin to that it has. You're gonna have more resin in the tank. I mean, you'll have resin in the tank when you're done, so you need to start off with more than your part. And that's maybe a trade-off with the resin printers, but since you can reuse the resin, it's not like it's gonna be wasted.
So you put the resin in here.
Yep. There's the build platform. The build platform goes up into this.
I'm gonna tilt you guys up slowly.
Okay, so this is gonna go up here, and this screws down and tightens up and hold that in place.
So the Z-axis uses that motor down there to move this build plate, and it's going to go down into the resin, and the first layer is going to be put onto the bottom of this.
Oh, you know what? I know what it is. Those springs that are on the bottom, that's for leveling the platform. That's what people complain about. So I guess if you leave the sides off here, you can more easily level it. But they have a new one that it actually uses. I think they use this to do it, or maybe it's down here. They have a new build plate.
So this is the build platform. This is where the resin goes in this little vat, and then underneath here, this motor is what moves it up and down, and it has to tilt after every layer, right? Because it has to re-level itself. Is that correct? So that's what this does. It tilts this whole platform, which I don't think I can manually do. And then under here, that's that motor. And under here is all the heart of the printer down below. So we have, this controls the X mirror. You can correct me if I'm wrong at any point. So this controls the X mirror, and this controls the Y mirror.
You're on camera.
X and Y, and then this is a rotary encoder, you said?
I think it's the motor, actually.
That moves the mirrors back and forth, and the laser's on the other side. So the laser is constant, and the mirrors are going to point upwards into that resin vat right there. And that's how it cures it. And then everything else just controls what is happening on the printer. So this is the... what do you do with this knob?
This is the rotary encoder. This is so you can go through the options and stuff on the screen.
So this is for the screen. The LCD's on the other side of there. This is the main control board right here. This is the SD card slot we installed. This is the power board. We haven't installed power. It's down there. And then that all gets routed over to there. This wire right here is the end stop. So it goes to the top of, it rods up the back and goes to the top to right here. And this is how you know you've reached the top. And it has the IR sensor we were talking about. Is there anything else you want to tell them?
No, I think that's that. No, is it IR or is that? It's not a Hall effect, is it? Could be, but we'll figure that out.
Oh, maybe because it's a metal piece.
Yeah, or it's
it could be a Hall effect.
It's a steel piece. It could be even be an inductive sensor.
That would be better.
But maybe it's just a piece of steel sheet metal because they can get the vertical profile real cheap. So cool. I think I'm satisfied with today's build.
So I put it back to chat mode so people could see us and say goodbye. If you want to sit down behind your printer. Tim says goodbye.
Yeah, that's my goodbye.
So thank you guys so much for hanging out with us today. We might do more of these kind of things in the future, probably shorter. This was a pretty long and elaborate thing. Usually I would say they would be half an hour to maybe an hour and a half in the future. But Thank you guys so much. If you have any questions about this printer, ask Tim. You can leave the comments below and Tim will answer.
Oh, Bill Peters said something.
Hey, Bill.
Time for lunch. Yes.
Yes. Bill, have you been here the whole time? Or did you just join?
Came for the important bit, if anything.
He did. The very end when we explained everything. So, we have to go visit Bill at some point. He's the one that I keep telling you we gotta go down to Florida and see.
Oh, okay. Okay.
So, thank you guys so much, and we will most of it. So, we will see you guys later. I gotta figure out which one is the right one to hit end on because we've never done OBS before. There we go.
Cool. All right. Thanks so much, and we'll see you next time.